Buenos dias, my friends. In this tutorial, we will learn how to build our very own AI chatbot using the ChatGPT API, vector embeddings, and the Vercel AI SDK. Believe me, these are the most important technologies you have to learn right now. Almost every new app that gets built now has some form of AI in it, often using the ChatGPT API. It's the most important skill to know in the future. I myself already work as a freelancer with this exact tech stack and I make good money with it, and I have even more projects in the pipeline. Big companies all add some kind of AI features to their existing apps, and it's omnipresent right now. If you want to stay relevant as a developer, this tutorial will teach you the tools necessary for this. This is the same tech stack I'm using myself to build AI apps. Okay, so we will use Next.js to build a note-taking app with AI integration. The note-taking functionality is pretty simple. We have a list of notes here. We can update these notes. We can add a new note with a title and an optional content. We can delete nodes, and we store these nodes in MongoDB, but you can use any database, doesn't matter. We also added dark theme, just because it looks cool, but the most important feature here is this AI chat box. This chat box works similar to ChatGPT, but the difference is that this AI knows about our nodes, so it can answer questions based on these nodes. For example, I have this one node here where my passwords are in. And I can ask the chatbot, what's my Wi-Fi password again? Then it loads for a moment, and then it tells me my password, which it found in this node. And since this is a large language model, it can do more than just search. It can also summarize stuff for me or do other tasks. For example, let's say I have this watch list here in this other node, and I want to get a random movie out of this list. Then I can ask the AI, please give me a random movie to watch from my watch list. And the AI is smart enough to do these abstract tasks. So let's try this out. And as you can see, we also implement response streaming, where we don't have to wait until all the text of the AI has finished loading. Instead, it gets streamed in letter by letter, just like it works in the ChatGPT web interface. And it gave me a random movie from my list, John Wick 4. We can also ask follow-up questions. For example, give me another one, and the bot is smart enough to understand that this new sentence is still related to our last question. So let's try this out. Again, we get streaming, and it gives me another movie from my list. Now, the cool thing about this app, this will work just as well if we had thousands of nodes. It doesn't matter if we have 5 nodes or 5,000, the bot will always find the relevant information in all our nodes. For this, we will use a technique called vector embeddings. Vector embeddings are basically what give our AI long-term memory. Because making a simple request to the ChatGPT API is not difficult. We could just send our 6 nodes to it and tell it to work with it. It gets more difficult once we have a lot of information, because we can't send an indefinite amount of information to ChatGPT. There is a certain limit of characters we can send to it, and also the more characters we send to it, the more we have to pay. So you don't want to send like 100 different nodes to the API, you only want to send over a few that are relevant to the current question. And again, this is where vector embeddings come into play. If you don't know what vector embeddings means, don't worry, you will learn this in this tutorial, and we will store these vector embeddings in a database called Pinecone, which you might have already heard of, but if you haven't, don't worry. We will use Next.js 14 here, the latest version, but these concepts and the underlying techniques of creating vector embeddings and making the ChatGPT requests works the same independently of the framework. No matter if you build a website in React or with some other technology, or if you are building a mobile app, creating the vector embeddings and making the ChatGPT requests always works the same, just the code is a little bit different. You don't need any AI pre-knowledge to follow along in this tutorial, but it's good if you have worked with Next.js before. If you haven't, you can watch my Next.js 13 beginner tutorial here on YouTube. I will put a link to it into the top right corner of this video. This beginner tutorial was built with Next.js 13 and not 14, but there haven't been any API changes in Next.js 14, just under the hood optimizations basically, so it's still just as relevant for Next.js 14. You can watch this beginner tutorial first, it's short and efficient, and then you will know everything to get started with Next.js, and you can come back to this tutorial here. For the UI, we will use TailwindCSS and a component library called Shadcn UI, which you might have already heard of. It's very popular at the moment. And of course, the layout is also fully responsive. So this grid here changes. Everything moves out of place, just as it should be. For authentication, because we can log in and out into our user accounts, we will use Clerk, which is an authentication provider, and it's really the fastest way to set up authentication with advanced session management features. So without any further setup, we get this user session management pop-up right out of the box, where we can see the different devices we are logged in with, our connected social accounts. We can upload a profile picture to our user account. They have two-factor authentication and all this advanced stuff. This will help us set up authentication quickly so we can focus on the important part of this tutorial. And just as a side note, I also made this logo here with AI. I created this with a free tool called Microsoft Designer. I actually created a YouTube short, which is only 1 minute long, where I explain how to create such a logo in 1 minute. Takes 1 minute to create this logo, and it's completely yours. It's copyright free because it's generated by AI. If you want to learn how to do this yourself, just type into YouTube search Coding in Flow Microsoft Designer or Coding in Flow AI logo, and you will find this very short video. So check this out as well. And then let's get started with this amazing AI app. Happy coding. Alright, as usual, I assume that you have Node.js installed and VS Code set up. If you haven't, again, watch my Next.js beginner tutorial where I show you how to do this. And as usual, I will give you two options. You can either set up the project manually yourself and install all the dependencies yourself, or you can take my starting code from GitHub, which I will put into the description under the video. In this starting code, all the packages are already installed. The benefit is that you will have the exact same version numbers as I'm using, and this project doesn't break in the future. If you set up the project yourself, then you will have the latest versions installed. They might be a bit different than what we are using in this tutorial. If you're very brave, set up the project yourself. But if you are a beginner, it might be better to use my starting code on GitHub. So again, the link to the starting code is in the description. You can download it from there, from GitHub. Then just open the project and run npm install in the command line to install all the packages. And any graphics and images that we use in this project are also already contained in the starting code, together with all the packages. If you download the starting code, then you can skip the manual project setup that we will do now. To set up a Next.js project manually, we go to the folder where we want to put it, and then we want to open the command line here. On Windows, we do this by holding Shift down and right-clicking, and then we open the PowerShell or the command line. I'm not sure how it works on Linux and Mac. I assume it works similar. You might have to Google this. But yeah, we need a command line that points to this folder where we want to create this project. And then we type npx create -next -app add latest. This creates a new Next.js app with the latest version. We run this with enter. When this text pops up, we confirm with a Y and again enter, and then we have to give our project a name. I'm gonna call this Next.js AI Node app. The name doesn't matter, it's up to you. Then we press enter. Would you like to use TypeScript? Yes. Would you like to use ESLint? Yes as well. TailwindCSS 2. We also want to use the src directory and the app router. So we confirm all of them with yes. Would you like to customize the default import alias? This time we select no. But again, you only have to do this if you didn't download my starting project. The starting project already has all of this set up. And then we wait until this has finished setting up the project. Okay, when it's done, we can close the command line, and then we want to open this project. So Next.js AI Node app, here it is. We open it in VS Code. And then we need to install some packages. For this we open the terminal. If you don't know how to open it, you can click here on View. And with this button you can open a new terminal or with the shortcut next to it. Now we install the packages that we need. Again, in the starting code they are already set up. If you downloaded the starting code, then just run npm install without anything else added to it. This will install all the packages inside the package.json. If you set up the project manually, we have to define what new packages we want to install. So after npm install, we type in all of them, and we have to make sure that we don't enter any typos because they have very specific names. The first two are OpenAI, as one word, are lowercase, and AI, which is another word. The OpenAI package is provided by ChatGPT. This is how we interact with ChatGPT from our JavaScript code. And the second package, AI, is the Vercel AI SDK. This package was created by the creators of Next.js, and they provide very useful utility functions to interact with ChatGPT, implement chat functionality, and most importantly implement this streaming, where we get the response letter by letter, as you have seen earlier. This is all made easy for us with this Vercel AI SDK that we will also use. After a space, we also install Prisma, another space, and then add Prisma/client. Prisma is the ORM that we will use here. It's how we interact with our MongoDB database. Again, you can also use another database than MongoDB. Prisma works with a lot of them. You can check out the Prisma documentation if you want to learn more. Next, we install add Pinecone minus database/Pinecone. As I explained earlier, Pinecone is the database where we store our vector embeddings. This is how we give our AI long-term memory, and don't worry, they all have a free tier, so you don't have to pay anything to follow along building this project. Okay, but we still need a few more packages. The next is add Clerk/Next.js. Again, we use Clerk here. And then add Clerk/themes for dark theme support. Then we also need next-themes, which helps us implement the dark theme into our app. And we are almost done. We also use Prettier, which helps us format our code. This is especially useful with TailwindCSS because it automatically orders the class names for us, which makes it much less messy. And just in general, Prettier is an amazing formatting library. It's opinionated, so we don't have to worry how to format our code. If we should add semicolons or not, trailing commas or not, Prettier does all of this for us. I really like it, makes working with TypeScript code much easier. And together with Prettier, we also need the ESLint -config -Prettier, so that ESLint works properly together with Prettier. And one more, Prettier -plugin -TailwindCSS. This is responsible for ordering the Tailwind classes. And I just want to repeat one more time, if you downloaded the starting code, then you don't have to install all these packages. They are already inside the package.json. Okay, and this should be all. So let's execute this with enter. This will take a few seconds, or maybe a few minutes if you have a slow connection. Okay, after this is done, we can close the command line for now. Now we have all these packages here in our package.json. TailwindCSS was already set up when we created the Next.js project. Now it shouldn't matter if we install packages in the dependencies or dev dependencies block, because the unused production dependencies will be stripped away when we build the project anyway. At least this is how it used to work. And by default, all the packages used to be inside the normal dependencies block in a Next.js project. I don't know why they separated them again and created a separate dev dependencies block, but it shouldn't matter if we put dependencies like the Prettier plugin into dev dependencies or the normal dependencies block, because again, unused dependencies should automatically be removed when the project is compiled. So I'm just gonna keep them here in the normal dependencies block. Then, as I already showed you, I also prepared a logo for this app, which I'm gonna copy over into this project. I will also put a link to this logo under the video. If you set up the project manually, you can download it from there. But if you downloaded the starting code, the logo and the fav icon will already be in there. So for this logo, I want to create an assets folder inside the SRC folder here. So we right click on SRC, new folder assets. And then I just want to drag and drop this logo in here to copy it. Great. Next.js projects also have this generic fav icon by default, but I created a fav icon with the same logo, which is here. So let's delete the existing one and then drag and drop this into the app folder. It has to be placed inside the app folder. If you want to create your own fav icons, there are different free generators available. You can easily find them in Google search. You just upload an image here and it creates such a favicon.ico file, which you can pull into your project. But again, this is already contained in the starting code project. Okay, and then we also want to make sure that our IDE is set up properly, which is especially important when we work with Tailwind, because we need auto-completion and class ordering. And for this, we need another extension installed in the IDE. This one here, TailwindCSS IntelliSense. Go ahead and install this extension if you haven't yet. This gives us autocomplete in these class name strings, which is really important. You can't really work properly with Tailwind without this. Otherwise, you have to figure out each class by yourself, which sounds like a nightmare to me. So just go ahead and install this. And then we want to go into the project settings to set this up properly. So here on Windows, it's Preferences, Settings. And then in the search up here, we type in Files, Associations. We want to get to this setting here. And we want to add a new item where CSS files are associated with this Tailwind CSS string. So you just have to type in these values here. This makes sure that our Tailwind extension is loaded inside CSS files and we can use it there. And then we want to change another setting. Editor Quick Suggestions. There it is. We want to turn on quick suggestions for strings so that we get autocomplete for Tailwind classes inside these class name strings. Make sure to activate this. Then remember when we installed all our packages, we installed this Prettier-Tailwind-Plugin, and this also requires one file that we have to set up, this Prettier-config.js file, where we have to put in this code here. So let's go into our project. And in the root folder, even outside of SRC, right here, we create a new file, which we call Prettier.config.js. And in here, we put this code. You can type this out manually. This makes sure that automatic class ordering works, and by default we have to execute Prettier from the command line. But to execute this with a keyboard shortcut right in our IDE, I recommend that you also install this official Prettier VS Code extension. And after you have installed this, we go into our settings once again, and you can set the default formatter to Prettier, so that when you press the formatting shortcut, which on Windows is Shift-Alt-F, you can also search for this in a file where we have code. We can press Ctrl-Shift-P or Command-Shift-P on Mac. And this format document shortcut is how we format a document. And by setting the default formatter to Prettier, this is what will be used when we press this shortcut. So go ahead and set this to Prettier. And there's one more change we have to make. We go into the ESLint RZ JSON file. We want to change this string into an array, so we surround this with square brackets, and as the second value in here we put Prettier as a string. This makes sure that ESLint works properly together with Prettier. I know that all the setup can be a bit annoying, but it will really be worth it because it makes working with our project in the future much easier. That's the Prettier setup. I also recommend that you install these two extensions if you haven't yet. ESLint, which just shows the code warnings and errors directly in your IDE, so you don't have to run ESLint on the command line. And since we use Prisma as our ORM, I also recommend that you install this official Prisma extension. This will give you auto-completion and code formatting in your Prisma schemas, which is very useful. So go ahead and install this as well. This shouldn't require any special setup. You just have to install it and it should work right out of the box. And when we have installed all these packages and set up our project, we can close these tabs for now. Okay, and now we are ready to start coding. Okay, as I already mentioned, we will use Shadcn UI in our project, which is a very popular TailwindCSS component library for Next.js right now. It's based on another library called Radix UI, which are basically unstyled React components, and Shadcn adds styling to them, and it looks very clean and modern by default. One reason why this component library is so popular is that you don't install it as an npm package. You don't just write npm install. Instead, you basically copy-paste these components into your project, which means that you have all the code right in your project. You can change it if you want. You can update these components independently, so you own all the code yourself. And many people prefer this over having an npm package that you have to install, because then you don't really have access to the underlying code. You can't make changes as easily, and updates often break things. We can literally just copy-paste this code into our project. We don't have to install anything, but they also have these installation steps. Again, those are not packages that you install. Instead, it just creates some kind of configuration file in your project, which then automatically copy-pastes the component code into your project. So this is not the same as installing a package. It's basically just a more convenient way of copy-pasting. We will use this command, but again, I have already added this to the starting project. So if you downloaded the starting code, then you can just lean back and watch me set this up. It's already contained. I already added all the Shadcn components. The reason why I added it to the starting code is that just like packages, these components change over time. And if you watch this tutorial sometime in the future, I don't want your project to break because these components have different code now. This is why I added them to the starting code already. If you set up the project manually, then you have to follow along. So we need to copy this command here, the npm command, go back into our project, open the command line, and then run this. After this has finished loading, again we get asked some questions. Would you like to use TypeScript? Yes. Which style? We use the default style. They just look a bit different. Which color would you like to use as a base color? This is up to you. I'm gonna stick with slate, which is like a blackish color. Where is your global CSS file? Here we have to be careful because we have this src folder. So this default is not correct. Here we have to type src/app/globals.css. This is where our global CSS file is located, and Shadcn will make some changes to it. Would you like to use CSS variables for colors? We select yes here as well. I will explain this in more detail later. Where is your Tailwind config located? It's in the root folder right here, so the default is correct. Configure the import alias for components. We keep the default here as well. Configure import for utils. We keep the default here as well. Are you using React server components? Yes, we do. Write configuration to blah blah blah, proceed. We type in yes to confirm this, and then Shadcn sets up some files in this project. Okay, let's take a look at the files this has changed. So this Shadcn init command set up this components JSON. Later when we add Shadcn components, which we also do via the command line, it will use this configuration to decide how to set up these components. Again, we could also just copy paste the components, but this way it makes it easier to configure them properly, because it will be done for us automatically. It also installed some new packages. But again, the Shadcn setup is already included in the starting code, so you can skip this step there. Yeah, those are some utility packages it uses under the hood. This is an icon package. And then it also made a change to the global CSS file. It added some CSS color variables here, which we will later use. A primary color, a secondary color, and so on. More on this later. It also made changes to the Tailwind config. Now it created this Tailwind config.js, and we also have this Tailwind config.ts in our project. We don't need a TS file anymore. So let's go ahead and delete this. And all the Tailwind configuration is contained in this Tailwind config.js file. So here it basically wired up the color variables that we saw in the CSS file and some other configuration. On the Shadcn website, which you can find under this URL, you can also configure themes with different colors, and then you can get the code from here and you can copy this into your project, but we will use the default theme here. And then it also created this utils file with the cn function here. This is used to combine different Tailwind classes dynamically. We will see this later. Okay, and then the last thing to do is to install the actual Shadcn components that we want to use. Let's just install them all at once so that we don't have to keep coming back to this site later. Down here in the Shadcn documentation are the components. Again, this is already included in the starting project, because the code of these components might change in the future. So when you use Shadcn, you just install the components that you want to use in your project. And then you can always choose between manual installation, which is basically just copy pasting, or using the CLI, which will use the configuration file that we just set up. So we're gonna do this for all the components we will use in our project. So we copy this first one for the button back into our command line, and we execute npx Shadcn UI at latest add button. Again, this doesn't install a package, it basically just copy pastes the code of the button component over into our project. But we can change this code if we want. We have full access to it. Okay, and then we will need a few more. So we also need the card. So again, we scroll down to the installation command, copy the npm command, execute this in the command line. Now we get this card component. Next we need a dialog, and you can always see a preview of these components here. They look very clean and modern. Again, copy, run the command. We also need the form component. This makes working with forms easier, and it uses React hook form under the hood. We will learn how to use these components later. Again, we install this with this command. And this should also install some more packages, which are React hook form, sort, and the hook form resolvers here. Okay, just 3 more and then we are done. We also need input, which is this styled input field. Again, copy npm, run this. The input field automatically installs the label component as well. So we actually only need 2 more and not 3. So the last one is the text area, which is just a larger input field where we can change the size. So copy the npm command, run this, and this should be all components we need. Okay, and this is the exact state of the project that I will push into the starting code, with all the packages and Shadcn already installed, and the image files included, and going forward everything else we have to do manually. And the next step is to set up our MongoDB database and Prisma. Okay, we will use MongoDB Atlas for this project, which is a cloud-hosted MongoDB. They also have a free tier that we can use, so we don't have to pay anything. But if you rather use a different database, then this is fine as well. It doesn't really matter for the big picture of this tutorial. And we will also store our vector embeddings later in a different database. MongoDB is just for the nodes themselves. So you can search on Google for MongoDB Atlas and follow the link, create a free account. I'm gonna log in with the one I already have. And here we want to create a new cluster. I already have some clusters in here, so I click up here and create a new project. If you haven't created a project before, then there's probably a button right in the middle of the screen. Just follow along and create a new project, which we have to give a name. Again, I'm gonna call this Next.js AI Node app. Then we click on next. We don't have to change anything here. Click on Create Project. And then we click on Create a Deployment. Here we select M0, which is the free tier. The provider and region doesn't really matter. We can also keep the name as it is. Then we click on Create. We have to set up a username and a password. I'm gonna change the username to Florian. We can keep the auto-generated password. We need to copy this for later. And then we create this user. Where would you like to connect from? My local environment is correct. We add the current IP address, which is the IP address of our computer, but it looks like it has already been added for us. And then we click on Finish and Close. And then go to Overview. So this can take a few seconds or even a few minutes until this cluster is set up. And then we want to set up Prisma, which is an ORM. So it's the library that we use to interact with our MongoDB database more easily than using the native MongoDB driver. So on the Prisma homepage is this quick start guide, which brings us to the Add Prisma to an existing project page. This is all on prisma.io, but you don't have to open this page because I show you all the steps and code that we have to execute. We already installed Prisma in the beginning. So now we have to execute npx prisma init in our project. So let's open the terminal again, npx prisma init, which created two new files, I think. Yeah, it created the .env file with this connection string and this prisma schema. So let's open the .env file. Here is this placeholder connection string. We need to replace this for our MongoDB connection string, which we can find in MongoDB Atlas, where we left off. Here when we click on Connect and then on Drivers, we can scroll down and find this connection string here, which we need to copy. We replace the connection string in the env file. The username I set up is already inside it, but we have to replace this password placeholder here with the angle brackets for the password we set up earlier. And by default, I think the database is called test or something like that. To give the database an explicit name, we go after the slash here before the question mark, and then we can name our database, for example, node database or just database. The name doesn't matter. We save this file, and by default the .env file is not included in the git ignore file of a Next.js project, only this env.local. So we go at the bottom and add this to git ignore so that we don't push the .env file to GitHub if we decide to publish this project on GitHub. You don't need to put this on GitHub, but if you want to, you never want to push your credentials. So make sure to add .env to the git ignore file. Next we go into our schema.prisma file, which was created for us, and we change the provider from PostgreSQL, or however this is pronounced, to be honest I don't know, to MongoDB, because we are using a MongoDB database, and this down here connects the connection string in the .env file. And you notice that I have code highlighting and autocompletion in here, which only works because I have this Prisma extension installed, as I recommended to you earlier when we set up the project. Otherwise, VS Code will handle this like a plain text file, which is not so nice. In the schema, we also put all our models that we want to work with and that we want to store in our database later. In this project, it's only a single model for our nodes. So we create a model called node. And again, it's really nice to have autocompletion here. And then we add a few fields. The node needs an ID of type string with an uppercase S, space add ID, which tells Prisma that this is the unique ID of this model. We want to give it a default value, so it's auto-generated. So we type add default, and in here we have this auto function that we can call. Then after a space, we write add map, and in the string we write underscore ID, because in MongoDB IDs have this underscore in front of them. But in our code, we want to have just ID as the name. So this maps the real name of this field to the name that we use within our own code. And the last value we have to add to this line is addDB.objectID. This tells Prisma that this is not a simple string, it's a MongoDB object ID, which has to follow a certain schema. The other fields we add to this node model are simpler. Each node will need a title in form of a string. And now when I press the formatting shortcut, Shift-Alt-F on Windows, it aligns the code properly, which again is done for us by the Prisma extension. Then each node will have the content, which is the text of the node. We also make this a string, but we add a question mark after it, because this will be optional. We can also create nodes that only have a title. But each node also needs a user ID, so we know to which user this node belongs. And then we need two timestamps. One is called created_at of type datetime, and we set the default value to this now function. So the created_at timestamp will be created automatically. And then we need the updated_at timestamp as well, again of type datetime. And here we write add updated_at, which automatically updates this timestamp whenever we make a change to this document. So we don't have to handle this ourselves. Okay, these are the fields we need. In our code, this model will be called node, but it's convention that the collection in MongoDB has a name that is lowercase and plural. So again, we can use this map annotation here, but this time we have to write two adds because we want to map the whole collection name. So add map, and here we write nodes in lowercase and plural. So again, our collection will be called nodes, but the model that we work with in our code will have this singular name. Then again, we can format our code, and that's our whole schema for this app. Then we open the command line again, and we execute npx prisma generate, which generates the Prisma client that we can use in our code, which has this node model inside it. So whenever you make changes to your schema, you have to execute this Prisma generate command again. Otherwise, this model will be missing on the Prisma client. And then the Prisma documentation has these instructions on how to set up a Prisma client in the Next.js project. This basically creates a singleton, which makes sure that we always use the same instance of the Prisma client, which is necessary in development because when we save changes to our project, the server is restarted and this creates a new client. And if this creates too many clients, this can cause a problem. So we copy this code from the documentation. But instead of copying this, I recommend that you type this out by hand at least once, so you better understand what each line does. And we put this code into our lib folder. Shadcn actually created this lib folder when we initialized it earlier. In here we create a new file and we write db/prisma.ts. This db/ creates a new folder called db for our database code. And in here I paste this code. And again, you can pause the video now and type this out by hand, which will help you better understand what exactly is happening in here. But this basically just creates a Prisma client as a singleton and then exports it here so that we can use it throughout our project. And with this, Prisma and MongoDB for this project are also set up and we can soon start creating nodes, updating them, deleting them, and so on. Now, before we start adding nodes to our database, we have to set up authentication because each node should be associated with a particular user, right? So it's time to set up Clerk. For this, we go to clerk.com. I will also put a link into the video description. And here we create a free account. And again, they have a free tier available, so we don't have to pay anything. I'm gonna log in with the account that I already have. When we have created our account, we create an application, which we have to give a name. And again, I'm gonna call this Next.js AI Node app. By default, this has email and Google login enabled. We can enable more social providers later. And the cool thing is that Clerk also sends these emails for us. So we don't have to sign up for a separate email service. This is all handled for us. So we don't have to change anything else, and we click on Create Application. We can still make all the changes in our dashboard here later. On the next screen, we get our keys, which we can copy. Then we go into our project, into the .env file, and we paste them in here. Let's go back into the Clerk dashboard, and here they have this Continue in Docs button, which gives us some more instructions. Just make sure you have Next.js selected before you click this button. So we already installed the dependency in the very beginning, so we can skip this step. We also set the environment keys, just that we put it into the normal .env file and not .env.local, but this is fine. I want to keep them in the same file. The next step is to wrap our application into this Clerk provider context provider. This makes our session available throughout our whole app. So back into our project, into the layout.tsx file. And if you don't know what the root layout is, I explained this in my Next.js 13 beginner tutorial. And we want to wrap this whole application, this whole HTML tag, into a Clerk provider, but it looks like auto import doesn't work, so we have to import it manually. Import curly braces from @Clerk Next.js, and in here we should find the Clerk provider. And we want to wrap our whole application into this Clerk provider, which makes the login session available throughout our whole app. Okay, great. Let's take a look into the instructions again. The next step is to set up the middleware, which protects our routes. So we can copy this code here. If you use the starting code, then you want to make sure that your matcher looks exactly as the one I'm going to use. This shouldn't really change with future versions, but if it does, and you use the same package version as I do, then the matcher also has to match. No pun intended. And we have to put this into a middleware file, which we have to put directly into the SRC folder. Not inside app, but directly in SRC. And we have to name this file middleware.ts. This is a special file in Next.js that will be executed before we access any page. So I'm going to copy paste this here. So again, either copy paste this from the Clerk documentation or just type it out by hand exactly the way as I have it here. And this protects all routes by default. But we want to allow one particular route, and that's the front page. We want to make the front page available even when you are not logged in. So we can go into this auth middleware function here. And in here we have this public routes field, where, as the name implies, we can set routes that don't require authentication in form of an array that contains a string to a slash, so the home page. We can format this with Shift-Alt-F and then save it. And this is actually enough to get authentication to work. And to see that it works, let's create another page that's not the home page, so not our public route. So we right-click on the app folder, create a new file. We type nodes / again, this creates a new folder. And in here we put a page.tsx. If you don't know what a page.tsx is, again, you have to watch my Next.js 13 beginner tutorial. There I explain how routing works in Next.js. Okay, and for now we just start with a very simple page. We export a default function called nodes page, but the name of the function doesn't matter. You can call this anything you want. You can also just call it page, for example. And for now we simply return a div, which will say here will be your nodes. Just keep it simple for now. We save this, make sure the middleware and all the other files are saved as well. Open the command line, run npm run dev to run our Next.js project on localhost 3000. Then we open localhost 3000. The front page is public. It's not protected by Clerk authentication. But when we go to /nodes, we should be redirected to a login screen. Perfect. This is the default Clerk login screen. We can customize the design of this later, but the URL of this is not great. As you can see, it has this weird crucial pony URL. This URL is hosted directly by Clerk. They do this so that we can quickly set up authentication without having to set up our own pages. But instead of using these hosted URLs, we can also put this sign-in window into our own URL, which is better, right? So let's close this for now, go back into our project. We keep the development server running, but we can close the terminal. Then we right-click on the app folder, create a new file. And then we have to make sure the path is correct because Clerk looks for a very specific path. So in the app folder, we create a new folder called sign-in/. Then we have to write 2 pairs of square brackets like this. Not 1, but 2 pairs. In here we write ... and then sign-in again. This is a special so-called catch-all route. This is described in the Next.js documentation, but we don't have to understand this right now. This is just what Clerk expects to handle sign in and sign up later. But in here we want to put a page.tsx. So make sure the path is correct. And from here we can export our sign-in page, which uses the same sign-in component that you just saw a moment ago, just that this page will be located on our own URL. So it will be a very small component. We export a default function called sign-in-page. Again, the name of the component does not matter. And here we return a div, which is the page itself. And in here we put this sign-in component, which is an import from Clerk Next.js. This is the same sign-in form that you just saw a moment ago, just in form of a component that we can use in our own code. And then we want to center the sign-in component on our screen. So we go into the outer div and add some Tailwind classes. We make this a flex box with the flex class. And since we set up the Tailwind extension and the VS Code settings earlier, we get this nice auto-completion. If you're not getting auto-completion, then you might have to watch the beginning again and make sure your IDE is set up properly. With h-screen, we make this page as large as the screen. And then I want to center this sign-in form on the screen. And even though it's a meme that centering something inside a div is difficult, it's actually quite simple. We need a flex box with item center and justify center. And this centers the sign-in form on the screen. We can also customize this sign-in form. Remember the one we just saw had a blue color, but we actually use a blackish color as our primary color. So let's set this up as well. In the sign-in component, we have this appearance prop. And in between these curly braces, we add another pair of curly braces, because this is a configuration object. In here we have the variables field, colon, another pair of curly braces, and in here we want to set the color primary. You can do more customization, but this is the only customization I want to do here. We can set this to a hex string, and we will use 0f172a, which is just this blackish color that we use in our components. So I want to use this for the sign-in buttons as well. Okay, that's the sign-in page, but we also need a sign-up page, which will look almost identical. So let's copy this code and create another route in the app folder. This time it's called sign-up, again / 2 pairs of square brackets, ... sign-up. And in here we put another page.tsx. Here we can paste the code, but instead of sign in, we want to use Clerk's sign up component. This is used to create a new account, and let's rename the page to a sign up page as well. Okay, make sure everything is saved. Then we have to go into our .env file again and add these 4 environment variables. They tell Clerk where our new sign in and sign up URLs are located and where we want to be redirected to after we signed in. We want to get redirected to the /nodes page. So pause the video, type out these variables, make sure to spell them correctly. Let's save all the changes and then let's try this again. So again, I go to /notes. Again, we get redirected to the login page, but now it's located under our own URL. Much better, and it also has our own brand color. If you want to remove this branding here, then you will have to get a paid plan, but I think it's not a big deal, and it's really nice how well authentication just works when you use Clerk as a provider. Yeah, and we can switch between the sign up and sign in page, which are both located on our own URL. Let's try logging in with a Google account. And if you set up Google Authentication yourself, then you also have to create a Google app in the Google Cloud Console. But in development, Clerk provides this Google app for you, which is really convenient because it makes it easy to get started with social authentication pretty much instantly. So I'm gonna log into our Node app with one of our accounts. And once I'm logged in, I'm allowed to view the /nodes path. So now I'm logged in. We have created a new user in the process, which we should see in our Clerk dashboard. Yeah, total users 1, here it is. And we even get some confetti. We can find the list of all the users here in this user menu option. And in this dashboard, we can do a lot of customization. You can take your time and experiment and play around with this. We can also easily activate additional social login providers here under user and authentication, social connections, and you basically just have to turn them on. Again, in development, this just works. In production, you will have to set up an app for each of these social providers on their own homepage. So for example, for Google login, you need an app in the Google Cloud Console. Facebook also has a developer portal where you have to create an app. But in development, it's very quick and easy with Clerk. And yeah, as you can see, there are a ton of different providers available. Just for testing purposes, I'm gonna enable Facebook and I don't know, GitHub maybe. Now when we go back into our app, they should appear on the login page. Now we don't have a log out button yet, but what we can do is we can just clear the cookie where the JWT token is contained. So click up here, then on cookies, and then we remove them, reload the page, and we should be redirected to the login screen. So now we have Facebook and GitHub here as well, but I want to log in with the existing Google account again. So authentication works just like this. We can do some more customization here. For example, we can upload a logo under this branding option. So for example, we can upload our logo, right? Which is in the project, AI Node app, public. Now it's actually the assets folder in SRC, the Flow Brain logo, and for the icon as well. And again, this just works immediately. I'm gonna log out once again by deleting the cookie, reload the page, and now we see our logo here. It just makes this login screen a bit more fitting to our brand. Again, you can explore this Clerk dashboard further. There are many customization options. You can customize what data you want to store for each user. You can even enable multi-factor authentication and so on. But for our project, for now, we are all set. The last thing I want to do for this part of the tutorial is set the metadata of our website. So we go into the root layout once again. Up here is the page title and the description with the default text. I want to change this. I want to set the title to FlowBrain, which is the name I've given this app. And I want to set the description, which is shown, for example, when we post a link to our website on social media. But again, I explain this in more detail in my Next.js beginner tutorial. I want to set this to the intelligent note-taking app. So now when we go to our homepage again, we see the title FlowBrain up here. But I want to set a more specific title for the notes page. So in the notes page.tsx file, we export metadata here as well. Export const metadata, of type metadata, which is an import from Next. And in here I just want to overwrite the title. Again, I want this to say flow brain, but then a dash and then notes, because this is the notes page. Okay, after saving this, the home page and login page still says flow brain. Now let's actually also set a separate title for the sign in and sign up page. Makes sense, right? So we go into the sign in page. Let's set the title here as well. So again, export const metadata, of type metadata, title colon, again flow brain minus sign in. Let's copy this, save it, go to the sign up page, do the same here, add the metadata import and just change this to a sign up so that we have a proper title on all of these different pages. So let's save this. And now on the sign in page we see flow brain sign in. On the front page we see just flow brain, and after we logged in, on the notes page we should see the notes title, and there it is. Perfect, and now we can start building our different page layouts. Next I want to set up a navbar that we only show on the /notes routes, not on the home page or anywhere else, just everything under /notes. So let's go back into our project. We go into our /notes folder and I want to put the navbar component in here. You can name this anything you want. I'm gonna call it navbar in camel case like this. And for now I just want to export default a simple function with the same name that returns for now just a div that says navbar, just so that we can place it in our layout and see that this works. And as I said, I only want to put this navbar onto any route below /notes. So not on the home page and not on the sign in or sign up pages, but /notes. And if we add any nested route under /notes, like /notes/detail or /add node or whatever, I want to have the navbar there as well. So we can do this by adding a layout file into the notes folder here. We have to call it layout.tsx, just like the root layout down here, but this layout will only be applied to our /notes routes because we have it inside this folder. And this layout will look very similar to the root layout. So let's open this in the split view so we can compare them. So in our nested layout we export a default function which we call layout. Again, the name of this component is up to you. Only the file name is important. And in here we want to take the same argument as the root layout. The children, which is whatever we render inside this layout. Then we add the body to this function and we return a fragment like this with empty angle brackets. A fragment is just a way to put multiple components in here without having to declare another div. We could also create a div, but with a fragment we have one less unnecessary div. Instead, whatever we put inside here will be put directly into this children tag basically. And in here we put our navbar that we just created. And below we put the main tag, which is the main content of the page. In here I want to render the children, which is the page under the /notes route. And the cool thing is we have Prettier installed. This is why I didn't pay any attention to the formatting. It looks very ugly right now, but when we press our formatting shortcut, it all gets put in place. It even adds the parentheses for proper formatting. It puts the props into one line because they are short enough. And this is why I really love Prettier. It takes care of all of this for you and you don't have to think about it. But we also want to add some styling to this main tag. Again, we do this with Tailwind class names. With P4 we can add some padding of 1 rem or 16 pixels to all sides. Then I want to give this a max width of 7XL with this class name. so that the contents of the page don't go all the way to the left and right side. Instead, it can only be a max of 1280 pixels. And we get these hover suggestions again because we installed the Tailwind VS Code extension, which is really useful. So now that we have a max width, we also want to set the margin auto so that this main tag is centered on the screen. Okay, that's our node layout, and this will automatically be applied to all routes under /nodes, and it will be nested inside the root layout. So we have this root layout, in there is our /nodes layout, and in there is our nodes page. So when we go to our site again, we can see our navbar up here. And below we have our padding, and here you can see that this is centered on the screen, but on the front page we won't see the navbar, exactly as we wanted, only on the /nodes route. Okay, now let's finish setting up our navbar, and for this I put the browser and the IDE in split screen so we can see our changes immediately. So on this outer div we add some class names, again p4 for some padding, and then this shadow class, and again they are all provided by Tailwind. This, as the name implies, adds a shadow here at the bottom of the navbar. Again, I want the contents of the navbar to have a max width so that they can only be as wide as the content below it. So in this outer div we add another div and we can remove the navbar text. And here we add a bunch of different class names. First we make this a flex box, and then we use this flex wrap class to apply this flex wrap CSS attribute. This makes sure that on small screens, whatever is laid out horizontally will automatically be put vertically if there's not enough room. Then we can use this gap 3 value, which makes sure that the elements in this flex box will have a little gap between them, so they don't touch each other. Right now we can't see this yet, because we don't have any elements inside this div. Actually, what we can do just for now, we can maybe put 2 spans in here, which each have a text. Let's say element 1, element 2, just as long as we don't have anything else inside this div. Let's format this, and without this gap, there would be no space between these elements, but with the gap we have this little space, which will be applied to all elements inside this flex box. To make sure that they are centered vertically, we add item center, and then we also add justify between, which pushes one side of this div to the left and the other one to the right. And then again I want to give this a max width of 7XL and mortar to center this. And now our navbar looks like this. It has the max width and it has elements on the left and on the right side. And on very small screens, element 2 will automatically be pushed below element 1 for responsiveness. Nice. Since we added the Prettier-Tailwind-Plugin, we can press our formatting shortcut and it automatically puts these class names into the recommended order, which is just nice to keep a better overview. Again, we set up all of this in the beginning. If this doesn't work for you, then you might have to watch the setup part of this tutorial again and make sure that you set up the project properly. Okay, then I want to replace element 1, because instead of this text, I want to show our logo and the name of our app, like you can see it on most websites. We want to wrap this into a link, which we import from Next/link. Make sure to select the correct import. This is a Next.js link. We give this link an href. When we click it, it will lead to /nodes. We give this a class name as well. Flex, items center and gap 1. We know all of these attributes by now. Then we close this link. And in here we put an image. Again, this is an import from Next/image. So you should have these 2 imports now. And then we want to import our logo here. We have to do this manually. Import logo from. The name of this variable here doesn't matter, just the path to the logo. And we have this in add /assets/ and then here is the logo.png. We want to use this logo as the source of the image. We set an alt text, which will say FlowBrain logo. This is for screen readers. And then I want to set the width and the height of this image both to 40, and Next.js will automatically resize this for us so that we don't load this logo in an unnecessarily large size. Then we close this image tag, and then next to it, so below the image tag but still inside the link tag, I want to put some text which we wrap into a span. Yeah, and this will just say FlowBrain, and then we add some styling to the span. Just the font bold class, which I think is self-explaining. And there's our brand logo. And when we click it, we get to the /notes page, but we are already on this page. Okay, and then we also want to replace element 2 on the right side. But we want to put 2 elements on the right side. So we put another div in here, which is placed directly below the link tag, still inside this flexbox div. So right here we put another div. Again we style this div. Again with flexbox, item center and a gap of 2. And in here we put 2 elements. The first one is the user button, which is an import from Clerk. When we close this, we can see the Clerk user button here, which already shows our logo. And this is this pop-up from Clerk we get right out of the box. And in here we can do all the session management, which just works. We can also log out. We will do this later. For now, let's finish setting up our Navbar. In here we can do some configuration. For example, we can set an after signout URL. This is where we will be redirected to after we logged out. We want to get redirected to the front page. And then we can also style this user button a little bit more with this appearance prop. Again, we add another pair of curly braces here. Again, I don't care about the formatting because Prettier will take care of this for us. In here we have this elements field, again colon curly braces. And in here I want to style the avatar box. I basically just want to change the size of this avatar here. So avatar box colon, again curly braces. Here I want to set the width and height both to a string, 2.5 rem, and the same for the height, 2.5 rem. So when we save this, it gets a bit bigger. Lastly, I want to add the Add Note button to this layout. We put it right below the user button, still inside this div here, which is placed on the right side of the navbar. So this is an uppercase button. Uppercase because this is one of our Shadcn UI components that we installed earlier. So this is an import from our components folder. Uppercase button. The button will say add note. There it is with the default styling. And let's also add an icon here. So inside the button tag, but above the text, we write opening angle bracket plus, which is a Lucid React icon. So Lucid is this icon package that Shadcn installed automatically. We can define the size here, 20, and set the margin right with this mr-2 class name. Close this, and then we have a little plus icon in here. So let's save this. That's it for the navbar for now. So now we can log out via our user button, sign out. We get redirected to the front page. And now let's set up the layout of the front page as well. We will keep this simple. This page is located in our app folder, this one here, page.tsx. We remove all the default code here, so everything inside the return statement. And then we put a main tag in here. And then we will just build a little page with a login button. We will keep this simple. So we add some class names to the main tag. Again, we make this a flex box where everything is centered on the screen. So flex, but this time we also add flex col to make this a flex column so that all elements are aligned below each other instead of horizontally. We set the height to the full screen height. We use item sender and justify sender to sender the contents on the screen. And then lastly, gap 5 to add some spacing between the elements. In here we put another div, which will contain our logo and app name again. So again, this div gets class names as well, flex, items center, and gap 4. And in here we want to put our logo image again. So again, image from next image. Again, we need our logo. We can copy the import statement from our Navbar, paste it here. Oops. Set the src to logo. Set the same alt text as before. Flowbrain logo. This time I want to make the width and height a bit bigger, 100. There it is. And again, I want to put a text beside it. So we create another span, which says Flowbrain. And again, we add some class names to the span. First, we set font extra bold, which makes this extra bold. And then we set tracking tight, which puts the letters a bit closer to each other, which often looks good with larger text sizes. Because now we want to set the text to 4XL, which changes the text size. But on large screens, for example, full screen view like this, I want to make the text even bigger. And you can handle responsiveness in Tailwind with modifiers. So we can say on large screens with LG colon, we want to use text 5XL instead. So from large screen onwards, we will use 5XL, and LG, as you can see here, is 1224 pixels, and everything below will use text 4XL. So let's see. This should be text 4XL because it's a small window, and this is text 5XL. This is just one way of implementing responsiveness into your Tailwind layouts with these modifiers. There are also other modifiers like SM colon for small screens, MD for medium-sized screens, and so on. But these two breakpoints here are enough. Okay, cool. Then below this div, still inside our main tag, we put a paragraph tag with a description. An intelligent note-taking app with AI integration built with OpenAI, Pinecone, Next.js, Shadcn UI, Clerk. You will see the full text in a moment, so you can type it out yourself, and more. And now the cool thing about Prettier is that it even breaks up these large texts into separate lines, which I really like. So you can pause the video and type out this text if you want. Of course you don't need it. This is just so that it looks good. And then we add some class names to the paragraph tag. I want to use text center, which I think is self-explaining, but I also want to make this a bit smaller here, so that the text doesn't have such a large horizontal width. What we use this time is max width prose. Prose is a convenience class for text that can be read, basically, so like blog posts or any texts. We could also use something like the 7XL that we used earlier, but prose is just a nice class for text that should be read by users. So this is the max width it has now. Okay, and the last thing I want to add to the screen is a button that brings us to the notes page, or to the login screen rather. So here we use a Shadcn button again, which will just say open. But instead of a button, I actually want to render a link, because this will just link us to /notes, and you shouldn't use buttons as links for accessibility reasons. If you link to a page, then you should use a link HTML tag. But we still want the button styling, right? And Shadcn has a functionality for this implemented. We can add this as child prop to the button, which tells this button to not render an actual button HTML tag, but instead render whatever we put inside these tags here. And inside them we put the next link with an href to /nodes. We wrap the closing tag of this link around our open text here. We can also make this button a bit bigger with the size prop. In here we can select LG as a string. And now this is still styled as a button, but it's actually a link. So if we take a look at this HTML component, you can see that this is an A tag. So a normal HTML link, but styled as a button. So now it looks good, but it's also good for accessibility. For example, if someone uses a screen reader. One more thing I want to do on this page. If we open this page, but we are already logged in, I want to get automatically redirected to the /nodes page. You don't have to do this. I just want to show you how to do this. Remember that all components and pages are server components in Next.js 13 and 14 by default. So whatever code we put in here will be executed on the server and only the finished HTML will reach the client. Meaning that if we redirect in here, this will happen before the page is even opened. This way there will be no flash of the home page. We will not see the home page for a split second before we get redirected. We get redirected before we even see the page, which is exactly what we want. So what we do is up here, we want to check if the user is logged in. For this we can call this auth function from Clerk Next.js. This is not an async function, so we don't have to await this. But in here is the user ID, which we destructure between curly braces. If this user ID is defined, we know that we are logged in. So we can check if we have a user ID. Then we want to redirect, which is an import from next/navigation to /nodes. So if we are logged in, we want to redirect to the nodes page. So let's save this. We are not logged in currently. When we click open, we get to the login screen. Gonna log in with my account. We will see the nodes screen. When we try to open the front page now, we will get redirected immediately to the nodes page because we are logged in. If you don't want this functionality, you can remove this code here. But I think it's pretty cool. And similarly, if we log out on the nodes page, we get redirected to the front page and we have to log in again. Yeah, so now our whole authentication flow works. As I told you earlier, we can also upload a profile picture into our Clerk account. I'm gonna upload this beautiful flattering photo of mine just to show you that this works as well. And it's updated in our app immediately. Nice, and now we can start creating nodes, and each node will be tied to our user account, so that every user has their own nodes. Okay, before we add our AI chat, I want to implement the basic CRUD functionality, so that we can create nodes, update them and delete them. For the backend logic, we create an API route handler. For this, we right-click on the app folder, create a new folder called API. In here we put a folder called nodes to put this endpoint under the /nodes URL. And in here we put a route.ts to create an API route handler. If you have no idea what a route handler is, again I explained this in my Next.js beginner tutorial. We could also use server actions to handle the backend logic. Server actions are stable now, but server actions don't support the response streaming that we want to implement for AI responses later. And I didn't want to mix server actions and regular API endpoints in the same project, so I decided to go with API routes all the way. And to create a post endpoint here, we have to export an async function. Note that this is not the default export, it's a regular export, that's important. And we call it post in all uppercase. And this will take a request as its argument. Okay, this will be the endpoint to create a new node. First of all, we put a try catch block in here because we do database operations and they can always go wrong. If they go wrong, we want to log the error to the console. and we want to return an error response, which we do with this response class with an uppercase R, and we have this JSON convenience function on here, where we can return a JSON response to the front end. This JSON will have this error key with an error message, which will say internal server error. This is just meant for users to be readable. And after a comma, we add the configuration where we can set the status code for this response, which will be a 500 for internal server error. Okay, back into the try block. Here we want to get the request body, so the data that we send to this endpoint. We create a const body and we can get it from await rec.json. This JSON body will contain the node later, so the title and the content of the node that we want to store in our database. Remember that in our schema, the title of the node is mandatory, we have to pass one, and the content is optional. But on our backend, we have to verify that the user actually sent a title string in this body, because they might make a request where this title is missing, but then we can't make an entry in our database. This means we have to validate the body. We could do this manually by accessing these fields and checking if they are a string or not, but a better way is to use a proper validation library, which is especially useful later when you have larger schemas that you want to verify, which can also be a bit more complex. So let's do this properly. And earlier we already installed this SOT library. This was actually installed by Shadcn UI because it also uses this library under the hood for form validation. SOT is the most popular validation library and we can also use it to validate our request body here. So we have to create a schema for our node, and I actually want to reuse the same schema here in the backend, but also on the front end later for our form, where we type in the title and the content, because they both have to follow the same schema. So let's put the schema into a separate folder. We can put it into the lib folder. In here, let's put a new folder that we call validation. And in here, we put a file called node.ts for node-related validation. So from here, we export a const, which we call create node schema. And we assign this to z. And z is coming from SOT, we have to import this. Import z from the SOT package. And on here we can call this object function, with which we can create a schema for a node. This object has to have the same form as our node later. So in here we put a title, because this is what we expect in our node schema. And then we can create validation rules for this title. We can say this should be a z.string, which is a function. This will validate that this value is of type string, but the string should also not be empty. To check this, we can append this .min function and pass the number 1 to it. So this title string has to have at least one character. Still inside this min function, we add a comma, and between curly braces we can do some configuration. For example, we can customize the error message, because the default one is not very user-friendly. We want to set the error message to title is required, and this is also what will later be shown in our form as the error message if we try to submit a node without a title. But you will see this later. After the title, we add a comma and also add validation for the content of the node. Again, this is a z.string. But this time we append this optional function, because remember, the content is not required. We don't have to pass a body for the node. And now we can use this schema to validate our input whenever we want to create a node. And there's also another cool thing we can do. We can create a TypeScript type from the schema, which we also want to export here. Export type. Let's call it create node schema again, but with an uppercase C. Equals c dot, then we call this infer function, and between angle brackets we write type of create node schema, like this. And now when we hover over create node schema, we can see the TypeScript type and we can use this for type safety on our form later. And now we can use this schema to validate the body in our post route here. For this we create a const which we call parseResult equals. Then we import our create node schema which we just created, call.saveParse, and pass the body to it. This will now check that the request body adheres to the create node schema. We use saveParse because we want to throw our own error with our own error message and not use the default one. So below we check if !parseResult.success. So if the validation failed, then first of all we want to log an error to the console. We want to log the parse result error. And then we want to return an error response to the front end. So again we call response.json. Again we put an error key in here, which will say invalid input. And again we set the status code, but this time to 400, which is the HTTP status code for invalid request. If we get below this if check, it means the request body was valid, there is a title in there, and if there is content in there, it was a string. So now let's extract these values. We can destructure them from the parseResult.data. And in here we now find the title and the content with auto completion. But when we create a new node, we also need the user ID, right? We already know how to get it. We can get it from this Clerk auth function, which is not async, so we don't have to await it. But in here is the user ID. Again, the user ID can be undefined if no user is currently logged in. So we also want to check that the user is authenticated. So we check if !user ID. Then we want to return another error response. Again with the error key, which will say unauthorized. If we are not logged in, we are not allowed to create a node. And the status code for not authorized is 401. And then below this if block, we now know that we have a valid title, content, and user ID. So we have everything we need to create a new node. So let's create a const node, call await Prisma, which is an import from our lib folder, the Prisma client singleton we created earlier. On this, we can access the node model. If you don't have the node model on here, then you didn't generate the Prisma client. In this case, run npx Prisma generate again. You always have to do this after making changes to your Prisma schema. Otherwise, this client here is not created properly. Okay. On node, we can call create, parentheses, curly braces. Then we have this data field where we put the values of the node, which are the title, the content, and the user ID. Everything that a node document in our database needs. And the last step is to return a success response to the front end. So again, return response.json. In the JSON body between curly braces we put the node. It's good practice to return the document that you created back to the front end so that we can work with it there if we need to. And we set the status code to 201, which basically means new resource created successfully. And that's our create node endpoint. Before we create any nodes, we also need a way to see the nodes on the screen, right? So let's go to the nodes page where we want to show them. And for now, we will keep this simple. We will create an elaborate layout later, but for now, I just want to get something on the screen as quickly as possible. So again, pages in the Next.js app router are server components by default, which means that we can make them async and just fetch data in here. And this data fetching will be executed on the server, and only the finished layout will be sent to the client. This means we can fetch the nodes directly in here. We only want to get the nodes for the currently logged in user, right? So again, we call this Clerk auth function and get the user ID out of here. Now, since we have this middleware that protects this /nodes route, the user ID should always be defined here, because we can only reach this route if we are logged in. But TypeScript doesn't know this. TypeScript still thinks that the user ID could be null. So what we can do is we can check if !user ID, and since this is an unexpected state, we can just throw an error, because this should actually never happen. But if it happens for some reason, this means we made changes to our middleware accidentally. So let's throw an error that will say user ID undefined. And now below, TypeScript knows that the user ID is defined. So we can create a const all nodes, call await Prisma, which again we import from the lib folder, .node.find many. And in here we add a where filter, where the user ID has the value of the authenticated user, so that we only fetch nodes of the currently logged in user. And again, I want to keep the layout simple for now, so we just remove this "here will be your nodes" text. Instead, I want to put an expression in here between curly braces, and for now let's just JSON stringify all nodes. So we will just see them in plain text form. As soon as we save this, we see an empty array here because we don't have any nodes in our database yet. To create a new node, I want to add a modal dialog that appears when we click the Add Node button. So let's create a new component for this, and I want to put this into the components folder because we might want to reuse this dialog in different places later. Let's call it add node dialog.tsx. And we export a default function with the same name. For the dialog, of course, we use our Shadcn component that we already installed. This is how it looks. The usage is described in the documentation. And for the input form, we use the form components of Shadcn, which we can find here. This is basically a wrapper around the normal HTML input form. It can look a bit complicated at first, but the benefit of this is that we get proper input validation, where we can show different error messages in the UI if the input is not valid. It also adds proper accessibility features for screen readers, and it makes accessing the data of the input fields easier. Under the hood, this uses another library called React Hook Form. It also installed this to our package.json earlier when we set up the Shadcn components. This is the most popular form validation library for React. And it also uses SOT for validation. So let's go back to our project and set this up. First of all, this component needs props. So we go above, we create an interface, which we call add node dialog props. You can also give this any other name. This is just my personal preference. To it we pass open as a boolean. This way the parent that uses this dialog can decide if the dialog should be shown or not. And then also this setOpen function, which will also take an open boolean, but doesn't return anything. We will trigger this callback when we click the close button inside this dialog, and then the parent can change the open state to hide the dialog. Okay, we want to pass both these props to the add node dialog. So in here we destructure the add node dialog props, and in here are open and setOpen. Then we write const form and we call useForm. This is an import from React Hook Form that I showed you a moment ago. This is the form validation library that Shadcn uses together with its form components. To use form, we can pass a type argument between angle brackets. And in here we want to pass our create node schema with an uppercase C. This is the schema we created in our validation file. And this tells React Hook Form what data we expect in this form. Then we call this useForm function with parentheses, and in between curly braces we can do more configuration. We want to pass a resolver here. The resolver is what does the actual form validation. Here we can use the SOT resolver, which we have to import manually. Import curly braces, and we should find it from add hook form resolvers, which we installed earlier, /zod, and in here should be the zod resolver. We call this zod resolver here and pass our create node schema, but this time with a lowercase c, because this is the actual zod schema, not just the type. So now React hook form will use zod to validate our create node schema for our form input. Below, still inside the component, we create an async function, which we call onSubmit. And here we will receive the input of our form, again of type create node schema, because this is the data we expect. Title and optional content. For now, let's just keep this empty, or maybe let's show an alert dialog that just displays the input to see that this works. And we will fill this onSubmit function with code later. But below, of course, we want to return the actual component, the dialog that contains the form. So again, the syntax of these dialogs is described in the Shadcn documentation, but you don't need to read this, you can just follow along. Opening angle bracket dialog. And here is something important. You always have these two options, the radix import and the one from our UI folder. You always want to use the import from the UI folder because those are the Shadcn components. The radix one are the unstyled ones that Shadcn uses under the hood. So make sure to always select the correct import. So we import the Shadcn dialog, which takes two props, open, which is one of the props we pass to this dialog component, and onOpenChange, to which we pass setOpen. The first one decides if the dialog is shown, and the other one will be triggered, for example, when we close the dialog via its close button, so that we can hide it from the UI. We close this, and in here we put dialog content. Again, it's important that you import the component from the UI folder. This doesn't take any props, and we close it. And in here we put a dialog header. And in the dialog header we put a dialog title, and this is all responsible for proper styling. And the title will say add node. Let's save this for now, and let's already show the dialog in the UI so that we can see it while we are building it. I want to render the dialog in the Navbar where our add node button is. So we go into the Navbar component, and we put a state at the top of the component. So square brackets, show add node dialog, and the corresponding setter, set show add node dialog. And we assign this to a use state, which we initialize with false. As soon as we save this, we should get an error, because we can only use state in client components, and by default, components in the Next.js app router are server components. To turn this component into a client component, we go to the top of the file and add the use client directive. Again, I explained this in my Next.js app router beginner tutorial. And to render the dialog in the UI, we surround this whole div inside a fragment, like this. And below the div, inside the fragment, I want to render the add node dialog, which expects the open and setOpen props. So we set open to show add node dialog. That's the state that decides if the dialog is shown. And for setOpen, we pass the state setter, so that we can hide the dialog. Now, if you have watched any of my previous tutorials, then you might also know that we could unmount the dialog like this. We could use our opened state and then decide if we render the dialog or not. The difference between this approach here and the approach where we use the open prop is that this approach will completely unmount the component, and this will also clear any input that we typed in. This approach here basically just hides the dialog, but it's still mounted. The benefit of this is that the input is still there after closing the dialog. And this is the effect I want to have here. I want to keep the input even if we close the dialog, so that we can continue writing our node at a later point. But this is just personal preference. Okay, and then we simply want to toggle the state when we click the Add Node button, right? So we add an onClick handler to this button. We add an error function, which will call setShowAddNode dialog and set this to true. And now when we click our Add Node button, we see our dialog. We can close it either over this button or just by clicking outside, but this behavior can be customized. So now let's finish setting up this dialog. Below the dialog header, but still inside the dialog component, we want to put this form component, which is an import from our UI folder, not the React hook form one. This is Shadcn's form component, which just makes setting up these forms a little bit easier. The syntax of this is described in the Shadcn documentation. For example, on the input component, when we scroll down, we see this section that says form, which describes how to wire this up. And we have a similar entry in the text area component and all the other form components. But again, you don't have to read this because I will show you how to set this up. So to this form opening tag, we pass curly braces and we spread this form variable from up here, because this React hook form object contains different values: control, get values, register, and so on. And this Shadcn form component uses these props. We don't have to understand what exactly it does with them internally, but it just works. Okay, into this uppercase F form we put a lowercase f form, which is just a normal HTML form. But this form will be managed by this Shadcn component. To this lowercase form we pass the onSubmit function, to which we pass form dot, again form is coming from React hook form. Here we call handle submit, parentheses, and to this we pass our onSubmit function, which we created earlier. This is just the syntax React hook form uses to wire this all up. The benefit is that later we get our create node schema values in this onSubmit function, the title and the content. Usually in HTML forms you get a form event and you have to extract your data out of there. We don't have to do this. Instead we get the data we expect directly. This is just one of the benefits that such a form library brings. And I also want to add a class name to this form to add some spacing between the single form elements. We add this space y3 utility class. This works without using a flexbox, and it adds some vertical spacing. Inside this form we use another Shadcn component, which is this uppercase form field, which we import from our UI folder. This gets a self-closing tag, and this component controls a single input field in our form. Again, the syntax of this is described in the Shadcn documentation. So this expects this control prop, to which we pass form.control. Then this expects the name of the form, and autocomplete should help us, because we already told React hook form that we expect a create node schema, so we get autocompletion here. The first one is for the title, and then we have this render function, which renders the input field itself. So to this we pass parentheses, inside the parentheses another pair of curly braces because we want to destructure this, and in here we have this field value. And this returns an error function. Make sure the syntax is correct. So right arrow, another pair of parentheses because we want to return a component here. And don't worry, the syntax doesn't get any more complicated. We only have to render our input field in here, and that's basically it. So in here we want to put a form item, which again is coming from our UI folder. We close this tag. A form item contains a form label, which is the label that is shown above this input field. This one will say node title. And then below we put a form control, and all these components are necessary for proper styling and input handling. And inside the form control we put an input with an uppercase I. The input again gets a self-closing tag, When we save this, we already see this in the UI. We can give this a placeholder, just like a normal lowercase I HTML input field. This is just a styled one. The placeholder will say node title. There it is. And then we destructure this field value inside this input component. This will wire it all up so that it actually works. One more thing we need to add. Below the form control, we put a form message. This form message will show the error message if we try to submit this with invalid input, so without the title. And the cool thing is, this just works. This will automatically show the error message of our create node schema, which is this message here. And this just works without us having to handle this manually. This is the cool thing about these Shadcn form components. The syntax can be a bit complicated the first time, but it gives us a lot of cool functionality out of the box. And again, you basically just copy paste this from the Shadcn documentation. I don't understand all of these components under the hood. I just know that they work if you use them properly. Anyway, this is the full syntax for a single form input field. And now we simply want to duplicate this form input field to create another one for the node content, right? So let's just copy paste this one time below. The control prop is still the same. We change the name to content. We change the label to node content. And the placeholder as well. When we save this, we get a second input field. But here we want to use a text area instead of a normal input field. Uppercase T, because this is a larger input field and we can resize this. But the rest works the same. And again, this is connected to our React hook form and our create node schema. Now we only need a submit button, which we put directly below our second form input field, still inside the form. For styling, we can wrap this into a dialog footer, which puts this at the bottom of the dialog. And in here we want to put a button that submits this form. But I want to create a button that has a loading state while the form is submitting, so that the user doesn't press it twice. The normal Shadcn button doesn't have a loading state, so let's create our own loading button. I put this into the UI folder because this is where Shadcn puts all these primitives. We could also put it one level up into the components folder, doesn't really matter. And I call this loading minus button. Usually I use camel case for components, but since Shadcn uses lowercase with spaces, I use the same naming convention here just for consistency. But it doesn't matter. You can use any file name you want. And in here I want to export a default function called loading button. This button needs props, so again we go above. This time we use type instead of interface, you will see why in a moment. And we call it loading button props. Equal sign curly braces. In here we pass this loading boolean, which will decide if the loading state is shown. And the reason we use type instead of interface is because then we can use a union type. This way we can basically extend these components. What do we want to extend them with? We want to extend them with the button props, which are coming from our button Shadcn component. Because this way the loading button will take the same props as a normal button plus our loading prop. And then we want to destructure these props here. So we add curly braces and we set the type of the props to loading button props. In here we will find the children. Those are part of the normal button props. This is whatever we put between the opening and the closing tag of the button. We have our new loading prop and we have the remaining props, which we can declare with ... props. Those are all the other button props except for children and loading. And then we want to return a special button here, right? So return opening angle bracket button. Just like any other button, this will render the children, but next to it, it will also render the loading indicator. So we add curly braces, we check if loading is true, two ampersand signs. If loading is true, we want to render the loader to icon, which again is a Lucid React icon. And then we style this with some class names. MR2 for some margin on the right side, H-4 and W-4 for the width and height. We could also set them with the size prop as we did earlier, but this basically has the same effect. It's up to personal preference. And right now I don't know what the size value for one rem is, so I keep it like this. And then we can use this animate spin class, which is another Tailwind class that rotates this loader so that we get an actual animation. And then we close this. So now we have our special loading button. And here in the opening tag of the button, we also want to spread all the remaining props. So any props that we pass to this button should be applied. And then we add one more prop. We set the disabled state of the button. This button should be disabled either if props.disabled is true. So if we just set the button to disable directly, or to vertical bars if loading is true. If the button is loading, it should also be disabled. Let's save this, and then we can use this loading button just like a normal button. We want to use it in our form here. So opening angle bracket loading button, the one we just created. It will say submit. There it is. The dialog footer wrapper is responsible for laying out this button. This is why it has the full width. Then we set the type of the loading button to submit. This is a normal button prop, and it tells React that this button should submit the form when it was clicked, which will then execute our onSubmit function. And the button also expects the loading prop. When do we want to set this to true? We want to set this to true while form.formState.isSubmitting is true. This is coming from React hook form, and this value will be true as long as our onSubmit function here is running. So it's an async function, and until this function returns, this loading state will be true, and we will show the loading state for our button. Okay, great. So our form is all set up. The last step is to actually submit our data. For now, let's see if the alert works. So first, let's try submitting this form without a title. We see our error message here, but we don't see the correct error message. This should be title is required and not just required, right? And I know why this happens, because this input is not a string with a length of 0 by default. It's completely undefined by default. When we type something in and remove it again, we get the correct error message. To fix this, we have to add a default value to useForm. And I also saw this in the Shadcn documentation. So we add this default values key to the useForm function. And in here we set the default values for both the title and the content to an empty string, so that these values are not undefined. Now let's refresh this and try this again. Yeah, now we get the right error message right away. Okay, and when we type in a title, we should see the value in the alert dialog. I didn't stringify it. Let's stringify this right quick. JSON stringify input. We will replace this in a moment anyway. And now there is the title and the content. And now we want to use this to create a new node, right? So let's remove the alert call and finish the onSubmit function. We do a fetch request to our backend here, which can always go wrong. So we wrap this into a try catch. Again, we want to log any errors that happen here. And if something goes wrong, I just want to show an alert dialog. It's not the greatest choice for UI, but I want to keep it simple in this tutorial. You can also add a proper toast or an error message to the UI, but I want to set this up as quickly as possible to focus on the important stuff. So this alert will say, something went wrong, please try again. A nice generic error message. In the try block, we make a request to our backend route handler that we set up earlier. So we create a const response, a call await fetch, just the native JavaScript fetch function, to our endpoint, which we put under /API. We don't have to add the base URL in Next.js. It prepends it automatically. and the route was /API/nodes, and then comma, and then we add the configuration of this fetch request. We set the method to a post to make a post request, and our endpoint expects the node content in the body, right? So we add the body. We have to stringify it to send it over the wire. And in here we simply want to send the input, which contains the title and the content. Okay, almost done. Below const response, we check if !response.ok, which means that we get a 400 or 500 response back. Then we want to throw an error here because something went wrong, right? And in this error we put a string that says status code : and then we append response.status, and we can see what exactly went wrong in our console later. If this request was successful, below I want to call form.reset, which resets the input fields, so they are empty again for the next node. And then we also want to update the UI to show the new node immediately, right? And this page, remember, is a server component. We fetch all the nodes server side, so we don't have any state in here. In order to refresh a server component, we simply call router.refresh, which basically fetches the data again. Some people think this is not optimal because we fetch all the nodes of this page again, but it's totally fine, and this is how you do it in server components right now. You just fetch the data again, because if you want to do more granular state updates, like putting a single node into our UI, then you need state. But you can't have state in server components. So instead we basically refresh the screen. For this we need the router. The router can only be used inside client components, but since the Navbar is already a client component and the Navbar uses the add node dialog, we don't have to add the use client directive here. We can if we want, but it's not necessary. And at the top of our add node dialog component function, we create a const router and call use router. Careful, there are two different imports. We have to use the one from next/navigation because the /router one only works in the old pages directory, not in the app router. So now we can use the router in this component, and below form.reset, we want to call router.refresh as I explained earlier. This will refresh the server component. And then lastly, I want to close the dialog. So we call setOpen and set it to false. This is the callback we pass to the dialog, which then changes the state. Okay, this was quite a bit of code and concepts, but these things are important. Now you know how to use Shadcn form components. Now let's try adding a node. So again, we click this button. Again, we have our input validation. Let's say my first node. This is my first node. Submit, which should make a request to our /API/nodes endpoint. We have our loading state. And after we submitted this, we automatically refresh the server component. And this is the data of our new node that we created, which is also still there after refreshing the page. Amazing. Just to make sure that our user ID filtering works properly, let's log out with this user and log in with another one. I log in with my other Google account, which I think I haven't used in this app yet. Here it creates a new account and the array is empty as it should be. And as you can see, if the account doesn't have a profile image, it automatically uses the initials of the name, which is another cool Clerk feature. Okay, sign out again into the other account and we should see our node again. Okay, now let's create a component for these nodes that actually looks good. Okay, let's create a node layout in our components folder. So right click on components, and if you're wondering why I always have to click 2 or 3 times, my mouse is broken. Anyway, in here we put a node.tsx and as usual export default function with the same name. Of course we have to pass the node data to this node, so we create an interface for the props, node props, And to it we want to pass a node, and we import this node type from Prisma client. This is automatically generated from our schema, and it contains all the data of a node from our database, including the timestamps and the IDs. Now the component and this node type have the same name, and to avoid confusion I want to rename this import, which we can do with s. I want to rename this to node model, and this is the name we use here for the prop. Okay, cool. Then we destructure these props here. And then let's set up the layout. First of all, I want to create a variable called wasUpdated. This will be true if we updated the node, so that we can show a little updated indicator, just so that it looks better. For this we can simply check if the node updated timestamp is greater than the node created at timestamp. When we create a new node, these two will be identical. If we update a node, the updated timestamp will be set to the moment when we updated it. Simple. And in the node, I want to show either the created at or the updated at timestamp in user readable form. So we create a const created updated at timestamp. This will contain one of these two values. Here we add parentheses. Inside we check if wasUpdated is true. Then we want to use node.updatedAt. Otherwise, colon. We want to use node.createdAt. And I wrap this into parentheses because on either of these two values, I want to call toDateString, which turns this into a human readable form, which we can then show in our UI. And then below we return the UI. For this I want to use a Shadcn card, which we import from our UI folder. Again, the syntax of this is described in the Shadcn documentation. Into the card we put a card header. Into the card header we put a card title. The card title will render the node title, of course. And before we finish this, let's save it and put this in the UI. So we go to our nodes page, where right now we just stringify the nodes. Instead, we add an expression, take our all nodes array, and then we want to map this to a layout. So map. In here we take each node and render a UI element. The element we want to render is of course our node component that we just created, which expects the node as input. And since we call the map function here, we also have to add a unique key. For this we can simply use the ID of the node, which is unique between each node. Okay, and when we save this, we already see our node in the UI. It has the full width right now, but instead I want to render a responsive grid. So we go to this outer div here, add a class name prop. We use the grid class. We add a gap of 3 to add some gap between the different nodes. Maybe let's add a second node so we can see this difference. My second node, blah, blah, blah. Submit. The UI refreshes, but we still have our list. To show multiple columns, we have to use the grid cols class. For example, grid cols2 creates 2 columns. But I only want to use 2 columns on small screens and upwards. On very small screens, I want to show only a single column. So we add the SM modifier here. So now this depends on the screen size. This is extra small and this is just small. And similarly, on large screens, so LG colon, I want to use grid cols3. And just like that, we get a responsive grid. 2 columns, and eventually we get 3. The last one will be placed here on the right side. Third node, oops, blah, blah. There's the third one, and this is how the grid is responsive. When we press our format shortcut, it all looks nice. If our nodes are empty, I also want to render a text that says, yeah, you haven't created any nodes yet, or something like that. So we add another expression below our map call. We check if all nodes.length is equal to 0, 2 ampersand signs, parentheses. Then we want to render another div, which will say you don't have any nodes yet. Why don't you create one? But we have to escape these single quotes. We can either use this special value here, but it's not very readable. What we can do instead is we can turn this into a string expression. This should also work. Just to see that this works, let's change this to not equal to 1 for a moment. And let's comment this out. I will add this back in a moment. There's our text, but it's inside the grid, so it only takes up 1/3, which looks not very good. But we can change this by adding some styling to this div. We add col span full, which makes this take up the full available width of the grid. And with text center, we can center the text. So now it's in the middle, much better. Then we set this back to equals 0, and we remove the comment up here so that it's displayed properly. Okay, great. Now let's finish the node layout. So still inside the node header, but below the title, we add a card description, which will contain the created updated add timestamp, which is already formatted to a readable text. And then if was updated is true, so if the updated add timestamp is shown, I also want to show a text that says updated in parentheses behind it. So still inside the card description, we check if was updated is true. Then we want to render a string with a space, parentheses, and this says updated. We can't see it yet because we can't update nodes yet, but we will see this later. Okay, great. And lastly, below the card header, I want to render the card content. In here, I want to add a paragraph to which we add the class name whitespace pre-line. This way we make sure that any line breaks and any formatting is maintained in here. So if we write our node over multiple lines like this, then it will also be shown like this here in the cards. Otherwise it will put everything into one line, which doesn't look good. Yeah, and in this paragraph tag, we simply render node.content. And that's it. Now we have our properly formatted nodes inside a responsive grid. And the next step is to add update and delete functionalities for our nodes. After all of this base functionality is done, we can finally implement our AI chatbot. To update and delete nodes, we need new route handlers. So let's go into our node routes.ts file where we already have our post endpoint. And now we add 2 more endpoints. So again, export async function. We use a put request for updates. We could also use patch, but since we replaced the whole node, I think put is more idiomatic, but it doesn't matter. This receives the request just like the post function. And again, we have a try catch block and we use the same error response as in the post endpoint. The rest looks very similar to what we did in the post endpoint. We want to get the body and then we want to validate it. But we actually need a new validation schema because when we update a node, we expect the same title and optional content, but also a node ID, right? So that we know which node we have to update. So let's add a second schema. Export const update node schema. And the cool thing we can do in Zot is we can reuse the schema that we already have and then extend it. So we take the create node schema, call extend, parentheses, curly braces, and then we can add another value to it. We expect an ID, which is a z.string, which again should not be empty, so we add min1. Now we could also validate that this is an actual object ID and it has the structure of a MongoDB object ID, but this is unnecessarily complicated. We can also just check that we pass a string for the ID, and if the ID is not valid, it will not find an entry in the database. We don't need to export a type for this because we don't use this inside a form, but we also need a validation schema for deleting nodes, so let's create another one. Export const delete node schema. This time we don't extend the existing schema because this time we only need the ID. So we create a new c.object, and in here we put the same ID value as up here. Okay, then let's go back to our route. We can actually copy more code from up here, so we don't have to type so much. Let's copy everything from const parse result to right here above where we created the node. So let's copy this and paste it down here. We just have to make a few changes. We don't want to use the create node schema here. We want to use the update node schema. We can still use the same error message, invalid input. From our destructuring declaration down here, we can now also get the node ID. Now before we get the user ID, we can also check that this node actually exists. Otherwise we can't update it, right? So let's create a const node and assign this to Prisma.node.findUnique, parentheses, curly braces. For the filter we use where ID, so where the IDs match. And then below we check if !node, so if this node does not exist, then we want to return another error response, another JSON, which says error node not found. And the status code for not found is 404, so let's use that here. Then below we check that the user is actually authenticated. But additionally, we also need to check that the user ID is actually authorized to edit this node. Otherwise, any user could try to edit any node. So we check if !user ID, or if user ID is not equal to node.userID. So the user ID who created this node. Then the user is not authorized to update this node. Okay, then we need to actually update the node and return a success response. So const updated node equals await prisma.node.update, parentheses, curly braces. We need the where filter, where the IDs match, because we want to update a specific node. And for the data, we pass the new title and the content, which is part of the body that we send to this endpoint. Okay, and then we want to send a success response back. Return response.json. In this JSON, we put the updated node. And for the status, we use 200, which means success. But not 201, because we didn't create a new node, we just updated an existing one. And then we also need our delete endpoint. And for this, let's actually copy paste the whole put endpoint so that we don't have to write it from scratch. We change the name of the function to delete to create an HTTP delete endpoint, and post, put and delete are all HTTP methods. Those are all methods that we can use with the fetch function. These names are not arbitrary. They are only very specific names you can use here. Okay, we want to pass the input from the delete node schema. And the delete node schema does only contain the ID. This is why we see an error down here. We still do the same checks if the node exists and if the user is authorized to make changes to it. But then we only want to delete it. And we will also not return it to the front end. So we just call await prisma.node.delete with the where filter for this ID right? And instead of the updated node, we just return a message that says node deleted with the same 200 status code. Yeah, this should say node deleted, not deleted. To update a node, I want to use the same dialog as we used for creating a new node. So I want to make some changes to the add node dialog, and I actually also want to rename it. So we click on the file, press F2 on Windows, otherwise right click and click on rename here. And I want to rename this to add edit node dialog. It should automatically update the import statement in the Navbar. Yeah, but we might have to save the changes. Otherwise you have to fix the import statement yourself up here. Then I also want to rename the component to add edit node dialog and the props. Add edit node dialog props. Of course the name doesn't change anything in its functionality here, but I want to name it properly. And let's also rename the state in our Navbar. Again with F2. Show add edit node dialog just for consistency. And Z show add edit node dialog. For now we close the Navbar. And what I want to do is I want to pass an optional node to add it to this dialog. If we create a new node, this value will simply be undefined. If we update a node, it will contain a node. So we add another prop, node to edit. We make it optional with a question mark. And this will be of type node, which again is coming from the Prisma client. This is our node type. We destructure this new node to edit prop down here. And then we can use it to fill the default values of our form. So right now we only have empty strings here, right? If we have a node to edit, then we want to use the title as the default value. If not, we want to use an empty string as before. And the same for the content. Node to edit content, 2 vertical bars, empty string. So if we open this dialog with a node to edit, then the title and the content will automatically be filled with the contents of the node we want to edit. Let's save this for now, and before we continue, let's try this out. Let's go to our uppercase node component. Because I want to render the update dialog for each node in the node component itself, the cool thing about this is that each node has its own state. So we can maintain the input for each node even if we close the dialog, because each node has its own dialog. For this we put a state into this node component, const, square brackets, show edit dialog, and set show edit dialog. And we initialize this with a use state of false. Again, to render this dialog, we wrap this into a fragment. And below the card, we render our add edit node dialog, the same one we also render in the Navbar. For open, we pass our show edit dialog state. For Z open, we pass the zetter of the state. And then, as opposed to our Navbar add node dialog, we also pass a node to edit here, which is the node that we render inside this component. So now that we have state in here, we have to make this a client component as well, because again, we can only have state in client components. So let's add a directive. And then we also need a way to open this dialog, right? I want to open it when we click on a card. And I also want to add a shadow when we hover over a card and set a proper cursor. So let's start with some Tailwind classes. With cursor pointer, we can turn the cursor into this one here that we also see when we hover over a button, this little hand. Then we use the hover modifier to set a shadow LG, but only when we hover over a node. But this doesn't have any animation right now. We can change this by adding the transition shadow class, like this. Now we have this hover shadow with an animation. And now when we actually click, we want to open the edit dialog. So let's add an onClick handler, which will call set show edit dialog and set this to true, right? And now when we click on any of them, we open still the add node dialog. We will fix this in a moment. But as you can see, the input is automatically filled with the existing node. And since each node maintains its own state, we can actually type something in here. We can click on another node. We can type something in here as well. And each of them maintains their own input, which is really cool because they don't share one state. Each of them has their own dialog rendered inside the component. Okay, let's go back to our dialog and implement the update request. So when we submit our form, we want to add an if check at the very top that checks if there is a node to edit. In this case, we make a put request, otherwise we make the same post request as we had before. So we cut out everything from the response all the way to form.reset. We keep router refresh and set open false where it is, because we want to execute this in both cases, no matter if we created or updated a node. And if there is a node to edit, in the if block, we want to make a put request instead. So we create a const response, await fetch to the same endpoint, /API/nodes. But the configuration is a bit different. For the method, we use put this time. And for the body, we pass json.stringify again, but this time we pass a JavaScript object here between curly braces, because this time we not only need the title and the content, but also the ID of the node, right? So we pass the ID here in this object, which is the node to edit ID. This is what our backend route handler expects for a node to be inside the request body. And after a comma, we spread the input here. Again, we need to check if the response was okay. So we copy paste this line. And this time we don't need to reset the form, right? So this is actually all we need. And this should already work, right? So let's click a node to open the update dialog. My first node, 1, 2, 3, submit. And we see our updated title and this little updated text here. Really cool. Now let's also add an option to delete a node. This is not handled in onSubmit, it gets a separate function. Async functional delete node, still inside the add edit dialog. This expects a node to edit, right? So we check if node to edit is not defined, then we just return from this function. But we will also not show the delete button if node to edit is not defined. Again, we make a fetch request, so we do this inside a try catch block. We copy paste the same error handling as up here. And then we also need a loading state for the delete operation. The loading state for post and update is handled by the form, but for deleting a node we need our own state. Let's put this at the top of the component, right here. Const square brackets delete in progress and set delete in progress, and as usual this is a use state of false. Okay, back down to our delete node function. At the beginning of this function we set delete in progress to true, and then in the finally block of the try catch, because we want to execute this in either case, we set delete in progress back to false. And then we make a fetch request to our endpoint. So as usual, we create a const response, await fetch to the same URL, /API/nodes. The method this time is delete. And again, this is a valid HTTP method. And in the body, we have to send the ID of the node we want to delete. Again, we have to JSON stringify this. In here, we expect the ID field. Again, this is what we set up in our validation schema on the backend earlier. And we want to pass the ID of the node to edit. And then the same as before, we check that the response was okay. Otherwise we throw an error. And then we also want to refresh the screen and close the dialog. And that's it. Now we only need to put a delete button into our UI. So let's go down to our existing submit button here. And above, we add an expression which checks if node to edit is defined. Then we want to render another loading button here, which will say delete node. There it is. It looks better on larger screens when they are next to each other. I don't know why the dialog footer doesn't add spacing between them by default. We can add one ourselves with a gap, for example of 1. Maybe this is a bit better than before. But this also adds an additional gap on large screens. So let's say gap 1 on small screens, but from SM onwards we want to set the gap back to 0. Let's see. Yeah, now we still have our gap on very small screens, on XS screens, but small and upwards we remove this gap. This is better. And since our loading button uses the same props as a Shadcn button, we can also pass the same props to it. And one of them is the variant, which can change the styling of this button. For example, we have ghost, which looks like this. We have outline. But for this delete button, we want to use destructive, which creates this red button. Then we have to add the loading prop. This button should be loading as long as delete in progress is true. But we also want to disable this button if we are currently submitting a node. So we add the disabled prop here as well. And the button should be disabled if form.formState.isSubmitting. The difference is that disabled will not show the loading indicator, because when we are submitting the form, we are not deleting a node, right? And vice versa, down here, in the submit button, we set it also to disabled when delete is in progress. And of course, we need an onClick handler on this button, because this doesn't submit the form. Instead, this should execute our delete node function. And we can also set the type of this to button. This will prevent that this button submits the form, like our submit button down here does. One more thing, I also want to change the title of the dialog, depending if we are creating a new node or deleting an existing one. So instead of hard coding add node, we turn this into an expression where we check if we have a node to edit. In this case, we want to render edit node and otherwise add node. Okay, cool. Now let's try this out. But I don't want to delete my first node because it has special emotional value to me. Maybe let's create another node and then delete it. So we click it, we can update it the same as before. Submit, it's updated, and we can delete it, which should have its own loading indicator. And boom, it's gone. Now normally you should add some kind of confirmation before you delete a node. You should not delete it right away or add an undo button alternatively. But here I didn't bother because I wanted to keep this part of the tutorial simple and not add 1,000 other dialogues and functionalities. So you can do this yourself. You can add another confirmation dialog before the user can actually delete a node. But yeah, now the CRUD part of our app is finished. There's one more step I want to do before we add our AI chatbot, and that is implementing the dark theme, because it looks really cool. How to set up a dark theme with Shadcn UI is also described in the Shadcn documentation. We already installed this Next Themes dependency in the beginning. Next we have to wrap this Next Themes provider into a client component. This is necessary because this use client directive is not contained inside this Next Themes provider, which is coming from a third-party package. So we have to wrap this into a client component ourselves. So let's go back into our project. We will use the theme provider on our root layout. So let's put it into the same folder, directly into the app folder. Here we put a theme provider.tsx file. At the top we add the use client directive, but we can actually use a simpler syntax than is described in the Shadcn documentation. We can simply re-export the theme provider from Next themes. So we destructure this here and we export it. We don't import it. This way we can use this theme provider inside our server components because we added this use client directive here. So this is all we have to do in here. And then we wrap our root layout with this theme provider. We can put it here inside the body. Here we render the theme provider and we put the closing tag below the children. To the opening tag of the theme provider, we add this attribute prop and we set this to a class. But I'm getting an error because this is the wrong import statement here. We don't want to import the theme provider from Next themes. We want to import it from our re-exported file. And now it works. And this class prop here means that when we change the theme, Next themes will automatically set a class name on the outer HTML tag of our whole website. When we enable dark theme, it will set this class to dark. When we look into the Tailwind config.js file, we have this dark mode class value up here. This tells Tailwind that it will look for this dark class on the HTML tag, which Next themes handles for us, and this will decide which theme we show, light or dark. The theme colors themselves are defined in the global CSS file. So we have our primary and secondary colors and so on, and down here are the dark colors, which will be applied by Tailwind CSS. We can also add a third option, falling back to the system theme of our device. But I didn't implement this here because I wanted to have a simple button with two states instead of a drop-down menu. So we will just have a dark and a light theme here without the fallback to the system theme. If you want to add this as well, you can take a look into the Shadcn docs. Okay, now let's create a button with which we can actually toggle the theme. And I want to put this into the components folder again because we might want to use it in different places. Theme toggle button. .tsx, export default function, theme toggle button. At the top, we destructure a const for which we call the use theme hook, which is coming from the Next themes package. We call this, and this gives us access to the current theme and the set theme function. And then from this component, we return a Shadcn UI button, which will let us toggle the theme. We add some props to the opening tag of the button. We set the variant to outline. You will see how this looks in a moment. We set the size to icon. We set the class name to rounded full to make this a circle. And then we add an onClick attribute, which toggles the theme. We add an arrow function here, and this will check if theme is equal to dark, then we want to set the theme to light, and vice versa. Then I'm gonna copy two icons in here and a span. I will explain them in a moment. Those are both Lucid React icons. Pause the video and type this out by hand. So those are two icons which will be rendered above each other. Both have the same width and height of 1.2 rem. Both have some animation, which just makes it look cool when we toggle between them. And here you can see that we use this dark modifier. This will apply a Tailwind class only on dark theme. So only on dark theme, the sun icon has a scale of 0, in other words it will be hidden, and only on the dark theme, the moon icon has a scale of 100, so only one of them will be shown. Again, pause the video, type this out by hand, and then in a moment we will see how this actually looks. Ah yeah, and this down here is only meant for screen readers, because this button doesn't have a text, it only contains icons, so for accessibility reasons we add this screen reader only text. Okay, then let's use this new theme toggle button in our navbar. All we have to do is put it in here. We put it above our add node button, so to the left of it. Here we render a theme toggle button and all the logic is already contained inside this component. And there it is. And now, just like that, we can toggle between themes. The colors are already set up, as I explained earlier, in the primary and secondary and so on colors in Shadcn UI. And the way this works, again, is that the next themes library adds a class to the outer HTML tag. We can see this when we go to the Elements tab. Here is the HTML of the whole website. As you can see, the class is set to light. When we change this, the class is set to dark. And this tells TailwindCSS which colors to use. Now we could also build this functionality ourselves. This is actually not that difficult. We wouldn't have to use the next themes library. However, the difficult part is to show the correct theme when the page is loaded. So when I refresh the page, the dark theme is shown immediately. If we build the theme provider ourselves, then usually the light theme is shown for a short moment because the theme is stored in local storage. And local storage is not available server-side, only client-side. So it can only be loaded after the page is already hydrated on the client. Next themes avoids this. To be honest, I don't fully understand how they do it. I just know that they inject some kind of script that loads the value from local storage in advance and then puts it into the HTML before the page is loaded. But again, I don't fully understand how this works. It's pretty complicated. This is why I use the next themes library instead of doing this myself. One more thing, the Clerk pop-up still has the wrong color because this is not styled by Tailwind. But we can fix this. Clerk also has a dark theme, which we can import from add Clerk themes, which we installed in the beginning. And in here we have this dark value. What we can then do is we can use our use theme hook to read the current theme. This is available in our client components because we wrapped our layout into the theme provider. And then in the user button appearance prop, we have this base theme value. And here we check if theme from use theme is equal to dark, then we want to use Clerk's dark theme. Otherwise we set this to undefined, which makes it use the default light theme. But this of course needs to be 3 equal signs. Okay, let's see. Now Clerk has the correct color as well. Isn't this cool? Okay, and now finally the base functionality of our node app is done. We have a cool theme. We can add nodes, delete nodes, update nodes, all the cool stuff. And now we want to implement the AI functionality. In order to use the ChatGPT API, you have to create an account on OpenAI.com, then log in and you get an API key here. When I created my account, they had a free quota that you get granted when you created a new account, like $5 or $10 or so, which lasts forever because these API requests are very cheap. You pay like a fraction of a cent for thousands of generated words. So yeah, create an account here, log in, get an API key. I already have one, which we then add to our .env file. I'm gonna put it right here, give it the same name, OpenAI API key, and obviously I will delete this API key after recording this tutorial, so don't even try using that one, it won't work. Unless I forgot it, in which case I might go broke. When we have that, the next step is to create a Pinecone account, because this is the vector database where we store our vector embeddings. So click on login or sign up and create an account. I already created one with this email address. And then you should see this screen. And Pinecone also has a free tier. Creating one index is free. So we click on create index. We have to give this a name. Again, I call this Next.js AI node app. Then we have to configure this index. And the first time I did this, I had no idea what I have to enter here. Dimensions. What the hell is dimensions? Dimensions is simply how big the vector embedding is, basically, how many numbers it contains. And I figured this out simply by Googling. I Googled for ChatGPT embeddings dimensions, and I found out that this has 1536 dimensions, and we use the cosine metric. This is also described in the ChatGPT docs. We can't even change anything else, and then we click on Create Index, which creates a database. We have already installed the necessary dependency in our project. Now we need the API key. We can get it here. We copy it into our env file here as well. We create a Pinecone API key and paste it here. And then we add 2 new files to our lib folder that allow us to interact with these databases. So right click on lib. The first one is OpenAI.ts. In here we want to get our API key from process.env.openai API key. I store this in a variable because I want to check if the API key is not defined. So if we forgot to set this environment variable, then we need to throw an error here so that we don't continue with an undefined key. OpenAI API key is not set as the error message. If the API key is defined, we create a const OpenAI and assign this to a new OpenAI. Looks like we have to import this manually. Import OpenAI from the OpenAI package. Then we call this constructor down here, parentheses, curly braces, and in here we pass the API key. And then we export default this OpenAI client from this file, and then we can use it throughout our app to make requests to OpenAI. Then we need a similar file for Pinecone. Since Pinecone is another database, I want to put this into the database folder. We call it pinecone.ts. Again, we create this const API key, which we assign to process.env.pinecone_API_key. Again, we check that this key is defined. Otherwise, we throw an error. Pinecone API key is not set. Then we create a Pinecone client, which we do with new Pinecone. Okay, again, we have to import this manually. Import destructuring from add Pinecone database Pinecone, and in here is the Pinecone constructor, which we call and configure. This time we also have to set an environment, which is GZP starter. This is somewhere here in the Pinecone backend, indexes. Yeah, here we can see it. This is the environment that we have to pass. And then the API key here as well. And then we need a reference to the index. So the index is basically one database. Our Node.js AI node app is an index. This is what we want to export here. Export const nodes index equals pinecone.index with an uppercase I and the name of the index. Let's copy it just to be sure. So this is the name. We copy this and add it here in the string. Okay, and now we are ready to create vector embeddings and store them in Pinecone. And I think I haven't properly explained yet what actually vector embeddings are. So you might have already used the ChatGPT API before. It's pretty simple to use. We send a text request to ChatGPT that we write in human readable language. So just like we would talk to a normal person. And then we get the response from the AI back. But as I explained in the very beginning, what if we have like 1,000 nodes in our database? We can't send all of them to ChatGPT because the more text we send over, the more we have to pay. And also there is a limited context window. So before we make our ChatGPT request, we have to find the relevant nodes in our database for a specific user question. And a vector embedding is a technique where AI turns a piece of text, it can be one sentence, it can be a whole document, into an array of numbers. This array of numbers has these 1536 dimensions that we entered when we set up our Pinecone index. So it is an array with 1536 numbers in it. And these numbers define the position in this many-dimensional space. This is what this graphic here illustrates. Now, why do we do this? The numbers in this array actually contain the meaning of the text. So let's say this little circle here on the outside is a text that says, my favorite activity is coding. If we turn this into a vector embedding, it would have a position somewhere here in the space. Now, if we have a similar text with similar meaning, for example, the question, what is my favorite activity? So both these sentences talk about activity. This means they have a very similar meaning, so they are close to each other. The numbers in each vector are very close to the numbers of the other vector. But if we have a completely different sentence, like on Sunday I ate ice cream, with a completely different meaning, then it will be placed further away from our other two vectors. And this allows us to query these vector embeddings by their meaning. So if we send a request, a question to the chatbot, we first search for the nodes that are very close in their vectors, and then we only send these to ChatGPT to work with. If this sounds complicated to you, don't worry, maybe you understand it better once we have actually written the code for it. We can create such a vector embedding simply by making a request to OpenAI. So let's go into our OpenAI TS file and add a function here. Export async function get embedding. The name of this function is up to you, and we will simply send a text to it. Then we make a request to OpenAI. Const response await OpenAI dot embeddings, and they have a really nice JavaScript SDK which is very straightforward to use. Embeddings.create curly braces. In here we have to define the model, and there is only one embedding model available right now, this one here, text embedding ADA002, and this model is also very cheap, so it really costs only a fraction of a cent for large amounts of text. And then we have to give it the input, which is the text that we pass to this function. And just like this, we can create a vector embedding. We just have to return it. So we create a const embedding. We find it in response.data. This is an array with only one element, so we access the index 0. And in here is the actual embedding. And as you can see from the TypeScript type, this is an array of numbers. Because as I explained, a vector embedding is a huge array of numbers. We will print this to the console in a moment. If for some reason the embedding is missing, which basically means that the request failed, we just throw an error, but this should basically never happen. Error generating embedding. But just to make sure we handle this here, and then we return the embedding from this function. Maybe let's also log the embedding here, just so that we can see it. Embedding. Then we go into our nodes route file, because we want to create an embedding when we create or update a node, with the meaning of the node inside this embedding. First we go to the bottom and create another reusable function, get embedding for node, to which we will pass a title string and a content which is of type string or undefined, because not every node has content. Here we want to call and return the get embedding function from the OpenAI file. And then we basically just format this node properly. So in here I want to put the title, then 2 line breaks to separate the title and the content. So we add a string with 2 \n. This creates a line break. And then we want to put the content in here. But if the content is undefined, I want to put an empty string instead. This just formats the nodes properly before we embed them. Okay, then we go to the post handler. Right before we create our node, we also want to generate the embedding. So above node.create, we create a const embedding, and we call and await get embedding for node, to which we pass the title and the content. This creates this embedding. And now we want to store this in our Pinecone database so that we can later search for it. Now here's the thing, if the Pinecone operation fails for some reason because the database is down, then I don't want to create the node in the MongoDB either, because I don't want to have a node without a vector embedding. And vice versa, if the MongoDB operation failed, I don't want to create the entry in Pinecone. We can do this by wrapping these two operations into a transaction. For this we use Prisma. So what we do is we create another const node, and we assign this to a await Prisma dot $transaction. This is how we start a transaction in Prisma. Inside this we pass an async function that takes this tx argument. Tx is also a Prisma client, but whatever Prisma operations we do on tx will be part of the transaction. And in here we add a function body. In case you don't know what a transaction is, with a transaction you can do multiple database operations, and they will only be applied if all operations succeed. If there is an error thrown inside this transaction block, then all operations we do on this tx client will be rolled back. They will not be applied. Now we only use Prisma for MongoDB, right? This is connected to our MongoDB database, so this executes a MongoDB transaction. This is not in any way related to Pinecone. So Pinecone operations are actually not part of this transaction, meaning that we can't roll back a Pinecone transaction. We can only roll back a MongoDB transaction. But we can work around this by first executing the MongoDB operation and then the Pinecone operation. So what we do is we take this part down here, cut it out and paste it inside the transaction, but we replace this Prisma client on the inside for tx so that it's part of the transaction. And still inside the transaction as the second operation, we do our Pinecone operation, which we do on this nodes index that we exported earlier. Here we can call upsert, which creates or updates an entry in Pinecone, and this expects an array of one or more entries. In this array we add another pair of curly braces, and here we define the data that we want to store in Pinecone. Each entry has an ID, and for the Pinecone entry we want to use the same ID that the node has. This makes it easy later to query for them. The values is the embedding itself. This is the embedding up here that we just got from ChatGPT. And then we can also store metadata. This is where we put the user ID of the user who created this node. And later we can filter by this metadata so that we only find vector embeddings for this particular user. And then at the end of this transaction, we return the node. So this is this node, and by returning it from the transaction, it will be put into this return value, and we can return it from this API endpoint just like before. Now, as I explained, Pinecone is not actually part of the transaction. But since we execute Pinecone second, this will still work. Because if we execute the MongoDB operation successfully, but Pinecone fails, this will throw an error, which will cause the transaction to be rolled back, which will undo this create operation on MongoDB. However, if the MongoDB operation fails, then we will not even get to the Pinecone operation. This is why the order of these operations is important. You must not put the Pinecone operation above the MongoDB operation. Then this transaction will not work. Okay, let's save this and try this out. First of all, I want to delete all the existing nodes because they don't have a vector embedding in Pinecone yet, right? So let's get rid of them. Gonna delete all of them one by one and start with a blank slate. Make sure you have saved your route file. And now when we create a new node, it should create a vector embedding, which we should print to the console and then also store in Pinecone. Let's already put some information in here. I'm gonna call this my favorites. My favorite color, blue. My favorite car, BMW. My favorite hobby, coding. Just so that we have something that we can search for later. Submit. There is the vector embedding. This is actually abbreviated here, but this contains 1536 of these little numbers, which define a point in the vector space which contains the meaning of this node. Isn't this absolutely futuristic? And now this should also be stored in Pinecone. So let's go back. Let's refresh the backend. And there it is. The user ID is stored in the metadata. We can filter by this later. The ID is the ID of the node, and values contains the actual vector values. Nice. Now let's do the same when we update a node. So we scroll down to our put route. Again, we go above our MongoDB operation. Create an embedding here, just like before. Await get embedding for node, to which we pass the title and the content. And again, we need a transaction here. So const updated node equals await Prisma transaction, to which again we pass this async function with the TX client. Again, we want to move this in here, change this Prisma client to TX, and then we want to make the same Pinecone upsert call. Await nodes index.upsert parentheses square brackets curly braces. We pass the ID, which we already extracted here. That's the ID of the node we are updating. The values again is the embedding, and the metadata is the user ID. And then at the end of the transaction, we return the updated node. This is necessary because if we change the contents of a node, we also might change its meaning, right? So we have to create a new vector embedding. And finally, when we delete a node, we have to delete the vector entry in Pinecone. Again, we do this in a transaction. One last time. Prisma transaction async tx. In here we put this line, call it on the tx client, and then we call await nodes index.delete one, and to this we simply pass the ID of the node we want to delete. Okay, let's test the delete functionality. I create a new node with some gibberish, just to have a new entry in Pinecone. Let's refresh it. There's our second entry. And when we delete it, there should only be one entry left in Pinecone. And voila, only one entry. And since we execute all these operations in transactions, the Pinecone and the MongoDB database will always be in sync. There should be no way for them to get out of sync. Okay, and just like this, we implemented vector embeddings into our app. Now the last step is to create our AI chatbot, use the vector embeddings to find the relevant documents for a user query, and then send them to ChatGPT to get an answer. This is the most exciting part of this tutorial, the payoff basically, so make sure to watch it all the way to the end. Okay, now I want to add a little chat box that appears in the bottom right corner of the screen when we open it, and that allows us to chat with the AI. So let's create a new component for this. Let's put it into the components folder. I'm gonna call it AI chatbox.tsx. Let's export a component function. Export default function AI chatbox. And the component will also take props. AI chatbox props. The color of the chatbox will decide if the box is shown or not. So open boolean and an onClose callback. And then we pass these props to the component itself, as usual. And as I already explained in the beginning, we will use the Vercel AI SDK. This is a package created by the inventors of Next.js, so it works perfectly together with Next.js, but also with some other frameworks, as you can see here, like Next and Solid.js. And it solves two problems. For one, it manages the chat messages and all of this for us. Now, this is something we could easily do ourselves, but it's very convenient to use this useChat hook instead. The more important feature is that this helps us implement this response streaming, where we get the AI response sent letter by letter. And this doesn't only look cool, it makes the app feel much faster because we don't have to wait until the whole AI response has been generated, which can take quite a while for large texts. Instead, we get streamed the response as soon as the first letters are ready, basically. And the Vercel AI SDK makes implementing the streaming functionality very easy. This is why we will use it here. Okay, we have already installed the package. Now we want to call this useChat hook up here. So we call not useCat, useChat. Looks like we have to import this manually. Import curly braces, and we should find it in this AI package /react. And in here should be useChat. We want to call this hook here. And again, this is coming from the Vercel AI SDK. And in this destructuring declaration, we have different values. For example, the messages, because again, this hook handles the chat messages for us. So it keeps the state, it automatically makes the request to our endpoint, and so on. For now, let's just destructure a bunch of different values that we will use. We will use the messages, the input, which is what we type into the input field of our chat box. Handle input change updates this input. Handle submit to submit the values and send them to ChatGPT. With set messages, we can change these messages here manually if we want, like making them empty again to clear our chat. Is loading should be self-explaining and error as well. There are more values you can destructure, and you can also do some configuration in this useChat hook, but we don't need this right now. Then we want to return a div that contains the chat box. Let's add some styling to this div. We want to display the chat box in the bottom right corner. So we add this bottom 0 attribute and right 0. So we position it in the bottom right corner. We add a z index of 10. Z index means that this will be shown on top of other elements that have a lower z index, because we always want to show this chat box on top, right? We set it to width full, but we set a max width, which we hardcode like this with square brackets, to 500 pixels. So on small screens below 500 pixels, it will take up the full width of the screen, whatever is available. On large screens, it will be at most 500 pixels wide. We add some padding with P1, and we position it on the right side of the screen, which looks good on small screens, so it will be positioned right here at the bottom right. But if we have a large screen, I want to position it a bit more towards the middle. I don't want to put it all the way to the right edge. So we use a responsive Tailwind modifier on large screens, so XL colon. We set right 36. So we override this right 0 pixel value with a larger value, but only on large screens. You will see how this looks in a moment. Now what we do is we take this whole string, we highlight it like this, surround it with curly braces, then we surround it with parentheses, and in front of it we want to call this cn function, which is coming from the libs folder. This function was created earlier when we initialized chatcn, and it's basically just a way to combine different Tailwind classes and have them override each other intelligently. Normally this is needed so that you can override these hard-coded values from the outside. For example, the button has BG primary by default, but we might want to pass a different color via the class name prop to it. Then the end takes care that the value we pass from the outside overrides the value in here. This is what this is for, but we can also use it to pass class names conditionally. This is why I use it here. So at the end of this function, we add a comma right after the string, and then we can simply add more classes. And I put it separately because here I want to add an expression, and this way we keep this more readable. If open is true, so if the chat box is opened, then I want to set the position to fixed, because only then this bottom and right 0 is applied. We want to set a fixed position. If not, we want to set display none, which hides this chat box. Maybe for now let's put some text in here, chat box, and render it on the screen to see it while we are building it. I want to create a separate component for the button that opens and closes the chat box. So let's create another component in the components folder. Let's call it AI chat button.tsx. Export default function. So at the top this will contain a state, chatbox open and set chatbox open, and we call useState and pass false as the default value. And then we return a component. We put this into a fragment because in here we want to render our AI chat box. We pass the open value, which is the chatbox open state. And on close we pass an arrow function, which sets chatbox open back to false. And then above in this fragment, we put a Shadcn button, which will say AI chat. And we also have to close this AI chatbox component. Next to the text in the button, I want to put a Lucid React icon, this bot icon. Set the size to 20 and add a margin right. And then we add an onClick handler to this button, which will call set chatbox open and set this to true. And then we can use this AI chat button in different places. I want to put it into the Navbar. I want to put it right after the add node button here. So the add node button is this one. So below we put our AI chat button, but all the state and all the logic is contained in these two components. So when we click this button, we see something down here. So let's finish setting up the chat box. Okay, let's remove this text. Here I want to put a button, but with a lowercase b. This is not a style Shadcn button, it's just a raw HTML button without any styling. This will be the close button of this chat. Here I want to render this X circle icon, which we give a size of 30. There it is, here at the bottom. And then on the button wrapper, we add an onClick handler, which will call the onClose callback, and some styling. A small margin bottom. We set MS auto and block, which moves this to the right side of this chatbox component. Now we could also add an onClick attribute directly to this X circle icon. They support onClick handlers, but for accessibility it's better to wrap this into a button because this way we can highlight this by tapping through our components. As you can see, now this is highlighted. This only works if we wrap this into a button, but it's important for accessibility. Okay, and below this closed button is the actual chat box itself, right? This div on the outside is basically just the wrapper that contains these two components. So in here we put another div. Add some styling to this div as well. We make this a flex box. We set a fixed height of 600 pixels like this. We also make this a flex col, so all the elements will be aligned below each other vertically. We set this to rounded, which will give this rounded corners. Maybe to see what we're actually doing here, let's set a background color first. And let's give it a border with this border class, which creates a border of 1 pixel. And there it is. Now we have this box with rounded corners. Let's also add a shadow XL, which makes it more distinguishable from the background. Inside this div, we put another div, which will contain the chat messages. But for now, we just write a text in here, messages, so that we see where this is aligned. And we set a class name on this inner div of age_full. So this will take up 100% of the available height. Okay, and below this messages div, we put a form, which will only contain a single input field. But this time we don't need a Shadcn form, we use a normal HTML lowercase form. For one, because we don't need input validation, but also because the form is handled for us by the Vercel AI SDK. This is where we can use a primitive form. We pass the onSubmit function, to which we pass the handleSubmit function that we get from useChat. Again, all the logic is handled for us by this library. We style it with class names. We set the margin of 3 and we make it a flex box and give it a small gap, because this will contain 2 elements, the input field and the submit button. So for the input we use the uppercase I from our components folder, simply because this one is already styled and it looks better. We give it a self-closing tag. This is managed by the useChat hook. So for the value we pass input. For onChange we pass handle input change, which both come from the useChat hook. And we can set a placeholder, say something. There it is, with the margin around it. Looks good. And below the input, still inside the form, we also put the submit button, for which again we want to use a styled button of type submit, because by setting the type to submit, we execute this onSubmit callback here. And this will just say send. And there it is. Looks nice. So now we have our chat box shell. We can close it and open it. It's placed on the right side. On smaller screens it will take up the full available width, whatever is left. And on large screens it's placed more towards the middle and not all the way on the right side, which I think looks better. Okay, and the next step is to set up our backend route, where we actually make the request to the ChatGPT API and get our chat messages. Now the way this Vercel AI SDK works is that this will automatically make a request to a route on our own backend. By default, this makes a request to a /API/chat, and it sends the chat messages there. So we can create this route, read these messages, and then make the request to ChatGPT. This endpoint can be customized if you want to give it a different URL. You can do this in here. I think this API key is the one where you can change the endpoint, but we keep the default one because this is fine. So this means we need a new route in our API folder. So let's right click, new file, chat/route.ts to create this folder and the route file. This needs a single post endpoint. So export async function post. As usual, we get the request. We wrap this into a try catch block, and I want to handle errors the same as over in our Notes app endpoints, log it to the console, and return an error response. Always the same. Then we need to read the body of this request, which again we get with await rec.body. And as I explained, in this body are the messages that the Vercel AI SDK automatically sends to this route. Yeah, this should be rec.json and not body. So we create a const messages and we assign it to a body.messages. But TypeScript doesn't know the type of this, so this is any right now. To get type safety, we can set the type ourselves. For this, we use this chat completion message type, which is an import from OpenAI. And this is an array of these messages. This is the type that the OpenAI API expects. It contains the role of whoever sent the chat message and the text of the chat message. Okay, and we will send these chat messages to the ChatGPT API. But I want to truncate these messages. I only want to send over the last 6 messages. For one, to save tokens and make our requests cheaper, but also because we retrieve the nodes relevant to our current chat history with our vector embedding technique, so that we can pass them to ChatGPT. But if we have a lot of messages in this array, then the vector embedding will not be very exact, right? Because there might be a lot of different topics we talked about with the AI, so there are a lot of different meanings in our chat history, and then the vector embedding doesn't know what to search for. So we narrow this down to the last 6 messages. So let's create a messages truncated variable. And to get the last 6 elements of this array, we call messages.slice and pass -6 to it. So now we have the last 6 messages, which contains user messages and AI answers, so the chat history. And now we want to turn this into a vector embedding so that we can search for the relevant nodes that fit to the current chat history and the query of the user. So let's create a const embedding. We call our getEmbedding function, which we created earlier in the OpenAI file. This simply takes a raw text, and to it we pass our messages truncated, which is an array. We have to turn this into a single string, which we can do with the map function. Here we get passed each message. We wanna get the content out of these messages, and then after the map function we want to join all of these messages with a line break between them. So we pass a string \n. So this way we simply take the text of each message and we join them together into a one big string with a line break between them. And then we take this chat history and turn this into a vector embedding. And the resulting string looks somewhat like this. The user might have sent a message, hey, what's my Wi-Fi password? The AI response, your Wi-Fi password is XYZ. Thank you. What is my phone pin? And then the AI responds again, and this is what we turn into a vector embedding. This whole string of chat messages. This is a very simple approach. It works quite well from my experience, but there are more sophisticated approaches to create these vector embeddings. For example, we could have another step where we send our chat history to ChatGPT first and ask it to turn it into a newer question to create a more exact vector embedding. But in this tutorial, I want to keep this simple so that you can get started with this topic. And from my experience, this approach works. So we just turn this whole chat history into a vector embedding and compare it with the vectors of our nodes. By the way, I'm currently building a little startup. That's my side project, smartdiary.co. You can check it out if you want. It's an AI-powered journaling app. It uses the exact same tech stack as I'm teaching you right now. And there I use the same approach when it comes to vector embedding. I take the last 6 messages, turn them into a vector, and then I compare them with the vectors of the diary entries. And this works quite well. So yeah, check out smartdiary.co. Would be really happy if you try it out. But yeah, there are more sophisticated approaches, and I think this is where a tool like LangChain comes into play. This is another library that makes it easier to combine different AI tools and have more sophisticated algorithms. We don't use LangChain here because frankly we don't need it. But if you want to see more advanced AI tutorials in the future where I use a library like LangChain, then please leave a comment under the video and tell me that you want to see more of these tutorials. Okay, let's continue with our code. We also need the user ID of the user who's making this request, which as usual we get from the auth function. And then it's finally time to make a query to Pinecone to find the nodes that have an embedding close to the embedding of our chat history, which again means that their meaning is similar. So if in the chat we talked about passwords, then it will look for nodes where the text also talks about passwords. So let's create a const vector query response, and we call await nodes index. We have used this variable before. That's what we export from the Pinecone TS file. And using it is pretty simple. We can call query, parentheses, curly braces. We have to pass a vector to it, which is the embedding we just created. We have to pass this top K value, which simply means how many results we want to return. So the higher this value is, the more nodes you return. And 4 is a good value, so we have 4 nodes that we send to ChatGPT. If you make this value higher, then it's more likely that you actually find the information you're looking for, but you also send more data to ChatGPT, which makes it a bit more expensive. So 4 would be a reasonable value. In my Smart Diary app, I actually use 30. So I use a quite high value. This is up to you. You can experiment with this. Now to see that this actually works, for now I want to set this to 1 to only return a single result. And then we can set a filter. And we want a filter for the user ID because of course we only want to find documents that belong to this particular user. Okay, and this way we fetch the vector embeddings from Pinecone. But remember, the vector embeddings don't contain the nodes themselves, just the ID of the node. So we also have to make a request to MongoDB. So let's create a const relevant nodes. We call await Prisma .node.find many, parentheses, curly braces. We add a where filter, ID colon. We want to compare the ID. Then we write in colon vector query response dot matches, which are the results we get back from Pinecone. And we want to map these matches. We take each map and we want to map them to the ID. So match.id. So this here creates an array of the IDs of the results we get back from Pinecone. And with this operator, we only return nodes from MongoDB that have IDs that are included in this array. Because remember, our Pinecone entries have the same IDs as the nodes in MongoDB. Okay, below, let's print the relevant nodes to the console so that we see that this actually works. So this will say relevant nodes found colon. And after a comma, we pass relevant nodes, which right now should only be a single one, but later this can be multiple ones. And then we make the request to ChatGPT itself, and we send the relevant nodes over to it. And if you have never used the ChatGPT API, the way this works is that you basically talk to it like you would talk to a human. Since it's a large language model, it understands natural language. So what we can do is we can start with a system message that gives the AI instructions. Again, we set the type to this chat completion message, which we already used above here for the messages array, but this is a single message. This will give us auto-completion, because each chat completion message needs a role, for which we have different options. Assistant is the AI, system is what we can use to give instructions, and the user is the user. Function is something different, you don't have to worry about this right now. We want to send a system message, which we can use for instructions. And each message needs a content, which is the message itself. This is another string. So here we can give the AI instructions. You are an intelligent note-taking app. You usually start with something like this. You answer the user's question based on their existing nodes. Period space, because I want to append more text, but I want to put this into a separate line just for readability. So with a plus, we can append another string. Then we say the relevant nodes for this query are colon. We add the \n to make another line break, and we append another string. And then we want to pass the relevant nodes to it. So we take the relevant nodes, which is an array, recall.map on it to turn it into a string. We take each node and then we create a backtick string. And then we just have to format this properly, because again, the AI basically reads like a human, so we have to make it readable for it. So this will say title colon. Then after a space, we interpolate node.title. Then we make 2 \n to add 2 line breaks. Content colon. Since content is multi-line, I want to add another line break, \n, and then $ curly braces. Here we put node.content. So this creates a text that looks something like this. Title, passwords, and then content, colon, new line, and then the content of the node below it, like this. But we also have to call .join on this to turn this array into a single string. Again, we join this with 2 line breaks. So if we have multiple nodes, then they will all be put into this prompt. Okay, and then we make the request to ChatGPT. So let's create a const response equals await OpenAI from the lib folder .chat.completions.create. Remember earlier we used the embedding endpoint. Now we use the completions endpoint, which is basically the chat endpoint. Parentheses, curly braces. Here we define the model that we want to use. Here we have different options available. GPT-4 is the most powerful one at the moment, but the cheapest one that is still very good is GPT 3.5 Turbo, that's ChatGPT. So this is the best choice for most apps, because it's much cheaper than GPT-4 at the moment. Comma, we set stream to true, which enables this response streaming. And then we pass the messages to it. Those are the chat messages from up here, plus our system message with the instructions. So we create an array, we put the system message first to start with this, comma, and then we spread our messages truncated to also send the last 6 chat messages together with these instructions. This is how you make a request to ChatGPT, and now we just have to return this to the front end. For this we use the Vercel streaming helpers. So we create a const stream. We use this OpenAI stream. It looks like we have to import this manually. So let's go at the top. We want to import 2 values from the AI package. One is the OpenAIStream and the streaming text response. And how to use them is described in the Vercel AI SDK documentation, but it's pretty simple. We take this OpenAIStream constructor and pass the response to it. And then below, we return a new streaming text response to which we pass the stream. And that's it. And the useChat hook we use on the front end already knows how to read the stream. And the request to this endpoint is automatically done by the useChat hook. So all we have to do now is to render these messages in the UI. So let's do this. Below, let's create a simple component to style a single text message. So we create a function called chatMessage. This will expect a message prop, and we declare the type like this. If there's only a single value in there, then I sometimes don't create an interface for this, because it's shorter to just declare it inline. So we write curly braces for the type, message colon, and the type of this is message from the AI package. Because this is a single text message, and we can destructure this message object. From it we need a role and the content, because this is what we want to put into the layout. And then for now, again, let's keep this very simple. We will style this later. For now, I just want to render a div that contains the role and the content. This won't look great yet, but it will be sufficient for now. Let's also add a margin bottom to each message. And then let's render these messages here, where right now we only have this messages text. Instead, we put an expression with curly braces. We want to take the messages and map each message into one of our chat message components, to which we have to pass the message itself and a key as usual, because we mapped this here into a list. Each message has a unique ID that we can use here. Okay, let's save this and see if our AI has life in it. Hi, user. And after a moment we get streamed our response. Isn't this amazing? Now we still have to add proper styling, and we will also add a loading state while the response is generating and before streaming has started. But for now this is already pretty sick, and this AI should know about our nodes because we passed the relevant nodes to the request. Let's create a few more nodes so that we can find information in them. So I added some random nodes, and remember we set the top k to 1. So it should only find one relevant node when we make a chat request. So let's clear the terminal and try this out. So for example, I could ask it, what is my Netflix password? So we open the AI chat. I also want to refresh the screen to clear the chat. We will add the clear chat button later. What is my Netflix password? This is the vector embedding, and this is the node it found. As you can see, it found the relevant node. Now since top k is only 1, if we ask about something different now from a different node, then it might not find the information because it will only fetch one node, and in the chat history we talk about the passwords and then about something else. So let's try a movie from the watch list. This will probably not work. Give me a random movie from my watch list. But again, the chat history is still polluted with our first question. So this will probably not work because it still finds the password node. And to solve this problem, we have to increase the top k value, because now we allow the AI to read 4 different nodes instead of just 1. So now if I ask this again, it should work. Can you try again? And the cool thing about these large language models is that you can talk to them like with a human. If I ask, can you try again, it will recognize that I'm still talking about my previous question. And now with a larger top k value, we get 4 nodes, and it gave me a random movie from my watch list, Barbie, which is on the node. Isn't this cool? And now let's finish the styling of our chat box so that it looks good. I want to show the user profile picture next to the user messages. In order to load this image from the Clerk server, we first have to add this URL to the next config.js file. So let's go in here and into this next config block. Here we add images, colon, curly braces, and domains. Looks like this is deprecated, so I guess we have to use remote patterns now. This should be an array with objects in there, so square brackets, curly braces. Here we set the host name to img.clerk.com, and I'm doing this from the top of my head right now because I prepared the code for this domains field, but this has been deprecated in Next.js 14 apparently, and we have to use remote patterns instead. Let's save this for now. We have to restart our development server in order for the changes to take effect. So we stop the execution and run npm run dev again. And then let's go into our AI chatbox component and then go down into the chat message component. Above the return statement, first of all, I want to get a reference to the currently logged in user to get the profile picture. We can get it via this use user hook from Clerk. And in here, we can find the user with all the user information. This works because our whole app is wrapped into this Clerk provider, which is a context provider, and with use user, we access the values in this context provider. Then I want to create a boolean is AI message, and we assign this to a role is equal to assistant. So that we don't have to repeat this here over and over again, we now have this boolean that tells us if this is a user message or an AI message. Okay, and then I want to style this outer div here. Again, we wrap this MB3 string into curly braces, parentheses, and use this cn function here again. I want to add some more classes. I want to make this a flex box with item center. And as the second value to this function after the string, we want to pass some logic again. And again, I use this cn function for better readability. Because here I want to check if isAI message is true, then we want to apply some classes, and if not, we want to apply some other classes. If this is an AI message, I want to use justify start to put this on the left side of the chat, and I want to give it a margin end of 5. If this is a user message, I want to do the opposite. I want to use justify end to put this on the right side, and a margin start of 5. Now, since we restarted the development server, we have to refresh the page to load this again. Let's create another AI chat. I'm gonna ask about my favorite car. What is my favorite car? And it answers. The AI is now aligned left and the user message is aligned right, but of course it doesn't look great yet. Let's remove these two divs with the role and the message for now and set this up properly. First of all, we put an expression here. Again, we check if AI message is true. In this case, I want to render this bot icon again, to which we add the classes margin right of 2 and shrink 0. Shrink 0 takes care that this icon doesn't shrink if the text gets too big. Then below we put a paragraph tag for the message itself. So this will contain the content. And then we style this as well. We use an expression here because we want to call the cn function. In the first string we add white space preline. Again, this is to maintain the formatting of the message. Rounded MD to give it some rounded corners. Each message should also have a border of 1 pixel. With px3 we can set horizontal padding, so left and right side. And with py2 we set a different vertical padding. And then again after a comma I want to put an expression into the cn function. Again we check if it's an AI message. Then I want to set the background to BG background, colon. Otherwise I want to use BG primary, which is our black color, or white on dark theme. And then we also have to change the text color and set this to a text primary foreground. As you can see, this already looks much better, but we are not quite done yet. Below the content, so on the right side, I also want to put the image of the user. Of course, we only render this if this is not an AI message. And then after 2 ampersand signs, we also have to check if user.image URL, and user could be undefined, so it adds the safeguard operator. Only if the user has an image URL, then we want to render a next image. The source of the image is the image URL, which is now defined. We set the alt text to user image. And we set the width and height to 40 pixels. And then let's add the class names. ML2 for some margin on the left and rounded full to make this a circle. It doesn't look right yet. Yeah, I think this is because the image is wider than it is higher. So it loads this in this small size. What we could do instead is we could actually load this a bit larger than we needed, 100, and then set the size with CSS. So let's try setting a width of 10, a height of 10, and use object fit cover with the object cover class to show this properly. This looks better because now it's loaded in a bigger size so that it actually fits in here. But if the text gets too big, we also need a scroll bar here. Let's see. Please write down some long lorem ipso dummy text. I want this to get bigger than the available height. Please add some more, and eventually it will not fit in here and the input field gets pushed out of the screen. To fix this, we go up here to the div that contains the messages with the height full. First of all, I want to add some margin top. I also want to set some horizontal padding. Looks better. And then we add a scroll bar with overflow Y auto. And now we have a scroll bar if the chat gets too big. Nice. Looks very cool. Our chat box still requires some polish. For example, I want this to automatically scroll to the bottom when a new message arrives. Otherwise, if I ask it some more, like thank you, this will be stuck at the current scrolling position, which of course is not nice. And I also want to add states for when the chat is empty or when there is an error, and I want to add a clear chat button. So let's do that next. We scroll up below our useChat call here. We want to create two refs. The first one is called input ref, and we do this in React with this useRef hook. We set the type between angle brackets, HTML input element, and we initialize this with null. You will see what this is for in a moment. The second is the scroll ref. Again, we call useRef. The type this time is HTML div element. And again, we pass null as the initial value. Ref allows us to access an HTML element directly. We can use this, for example, to set focus on the input field or scroll down in this chat history div when it becomes too big. We can do this via refs. And we have to set these refs on the elements that we want to access. So the scroll ref is for this div here that contains the chat messages. After the class names, we can pass a ref prop and pass the scroll ref here. And the input ref is the input field, which is down here. Let's assign the ref here as well. Oops, like this. Input ref. Then we'll scroll up again. We go below our refs and we create two use effects. The first use effect will be responsible for scrolling down whenever the messages change. So we pass the messages array as a dependency. So this use effect will be executed whenever messages changes. So for example, when we get a new message, then we want to scroll down. First we have to check if scrollref.current has a value because this is nullable. And we can scroll down with scrollref.current.scrollTop equals, and we assign this to a scrollref.current.scrollHeight. I got this of course from Stack Overflow. This is just how we scroll down in such a vertical scrolling ref. This should now already work. So let's write something else. I'm just gonna write thank you again. And still didn't work. I might have to refresh the page to load this again. Maybe I have restarted my development server. So let's try this again. Let's start with hi. Please give me some lorem ipsum text. I can't do this because, okay, apparently it wants me to change the way I ask it. Yes, please generate some. The behavior of this AI always depends on the system message we gave it. We told it that it's an intelligent note-taking app, so when we ask it for something like a lorem ipsum text, it acts like a note-taking app and not as a general AI. This is where we get this weird behavior. One please, one paragraph. And now, yeah, it scrolls down automatically, as you can see. So it didn't work before because I had to refresh the page, but now it scrolls down, and this even works with streaming. And I created this input ref because when we open the chat box, I want to put the focus on this input field automatically, which we do with another use effect. This use effect checks if open is true, and it will be executed whenever open changes. And if open is true, we want to take the input ref, again access current, and then we can call focus on it. So now we should automatically put the cursor into the AI chat when we open this input field, which is just a bit better for user experience. Next, I want to add a button to clear the chat history. We put it to the left side of the input field, still inside the form right here. We put an uppercase B button, and this button will not contain text, but this trash icon. There it is, but we change the styling of this button. First of all, I want to give it a title that says clear chat. The title is what appears when we hover over it in this little pop-up here when we hover over it. This is not a React component, this is rendered by, I guess, the browser or the operating system, but this is the easiest way to get a hover tooltip onto an element. We set the variant to outline. We set the size to icon, which makes it a bit narrower, but it shouldn't be that small. It gets shrunk because the input field pushes it away. And again, we can fix this with this shrink 0 class that we used before. Now it has the appropriate size. We set the type to button because it's still inside this form. And when we click this, it should not submit our form. And we avoid this by setting the type to button. And we give it an onClick handler to which we pass an arrow function, which calls setMessages and passes an empty array. So setMessages is part of the useChat hook, and this way we can make changes to the array directly, like making it empty in this case. Let's try this out. Hi. Yeah, we will add a loading state in a moment. And now we can clear this chat history. And since this array is empty, these previous messages will also not be sent to the backend with our next request, because they don't exist anymore. Okay, then the last thing I want to add is a loading state, an error state, and an empty state for this chat. We do this below our messages map call here, still inside the same div. Before the chat message starts streaming, we still have some waiting time, right? And I want to show a message while this is loading. We have this isLoading value up here that we can use while the response is loading. But isLoading is also true while streaming is in progress. But once streaming starts, I want to hide the loading message. And we can check for this with another boolean. Let's put it here above the return statement. We create a const last message is user, which will only be true until the AI has started streaming. And we check this by taking the messages array. We want to access the last element, which we can do with messages.length -1. Here we want to access the role. And we might have to use the save call operator here, because this could be empty, right? So add a question mark here. If this role is user, then we know that the last message is from the user. Then below the map call, right here, we add another expression where we check if isLoading is true and the last message is from the user. Then we want to render a loading message. And for this we will render a chat message, which is our own component. This expects the message object, right? And we can create one ourselves with curly braces. Here we set the role to assistant and the content to thinking, or whatever you want to use as the loading message. Now this shows an error because a message also contains an ID. Now we could invent an ID, but we don't need the ID down here in our chat message. We only need the role and the content, right? So we can tell TypeScript we expect a message, but we don't care about the ID field. For this, TypeScript has a utility class, which we add before this message type. It's called pick. We don't have to import this just works out of the box. We use this pick and we surround messages in angle brackets. And after message, we add a comma. And then we add a string and we can tell TypeScript what fields we want. We want role, vertical bar, and another string, content. This way we tell TypeScript we want a message, but we only need the role and the content and nothing else, not the ID. Now this has the same effect as just adding the role and the content separately as separate props, but this way we still get this nice auto-completion where we only have different roles that we can pick from. So now this doesn't require an ID anymore and our error up here is gone. So let's see if this works. Hi, it should show thinking for a short moment until it starts streaming. Thinking, and then it starts streaming. Much better. Now the user sees that something is happening. Similarly, if error is true, which again we get from the useChat hook, then I want to render an error message, so we put another expression below that checks if error has a value. Then we want to render a chat message as well, to which again we pass a message as an object. The role is again the assistant, and the content will say something went wrong, please try again, without typos. To try this out, we can return an error response from our backend. Let's try this out. Here at the top, throw error. Of course, we will remove this in a moment. Bazinga. I'm not sure if the Vercel AI SDK handles 500 responses as errors, but I would assume that it does. So let's save everything and try this out. Hi again. Yeah, something went wrong, please try again. And it also removes the last user message, which I guess makes sense. So this works as well. Let's remove this error here. And lastly, I want to add an empty state so that we show something when the chat is empty. We might have to refresh this. So once again below, another expression. I want to show this empty state only if there is no error, and if messages.length is equal to 0. Then we render another div, which we style with flex, age full, item center, justify center, and a gap of 3. And in here I want to put a spot icon again with its default size and some text that says, ask the AI a question about your nodes. So, and there's our empty state. And this disappears as soon as we have messages. Thinking, and when I clear the chat, we see the empty state again. Nice. Congratulations for building your own AI chatbot. Again, I think this is one of the most important skills to have going forward, because there are many job opportunities coming up with this technology, and almost all apps in the future will have some kind of AI integration, often ChatGPT. I didn't add deployment to this tutorial because I have covered this before in other tutorials. If you want to deploy this project, then check the last part of my Next.js e-commerce tutorial. I will put a link to the video in the top right corner. There you can go to the last part, the deployment part, and there I show you how to deploy this Next.js project with Prisma and everything, but it's very easy. And if you want to see more AI tutorials like this one in the future, maybe with more advanced features, maybe using something like LangChain, then let me know in the comments below, because only if you actually like these videos, I have a reason to make more of them. If you like this video, please leave a like. If you haven't subscribed to the channel yet, please do so. And then I wish you a nice rest of the day. Happy coding. Take care.